different platforms. Busitema. Is it open? Yeah, but it's not registration.
Presentation of the video, and then you want to finish presentation. Sorry about that. I think we didn't test the start. Okay, I'm going to start my presentation on data science and interdisciplinary research for thriving livelihood. So this was the theme of this Data Science Africa for a reason that we need to in developing world we have so many challenges. So why do we need data science in developing communities? So we need to improve our livelihoods. We need to improve communities. We need to improve the way things are done, specifically in Africa and all sub-Saharan Africa. So we chose this as the theme of the event for that purpose. And so maybe before I start, give a highlight of where we are. And it's nice that we didn't work at Busitema University. Which is also disciplinary campus now that we know. So here in Toronto, but we have other campuses outside this place, and that's why the element also interdisciplinary and multidisciplinary comes in, where different faculties should come together to collaborate to make research meaningful and all that. So from yesterday's Okay. From yesterday's summer school, which was really very successful tutorials. There was some. I imagine by the start of today, we already know why data science is important. Why we should be in this place. Why we should be talking about data. So different speakers gave different scenarios, different examples. But then we always meet terminology. What is big data? If I asked any of us here, what do you think? How big do you think? How much data do you be using for your project? Could anyone give like a shoot or how much do you think it has a limit? Or data is infinite. All should be infinite. Yeah. So there is this big terminology is fine. Big data, machine learning, vision. How do you differentiate them? So I will not get into that. Yeah, but in the 21st century, we know that data is the oil. Data is the new oil. So it's a big resource that everyone values. So as I start my talk, which is also brief. I'll hint these different activities, different things. So emphasizing on interdisciplinary research, giving highlights of examples of interdisciplinary research, and then those key factors that us institutions, government, and other key people that help us or those influencing factors that are interdisciplinary research. So about science, I think my colleague is going to come and talk about it. But this is the shape of data science, which has been other countries like this holding here today. So in Uganda, we are here for the second time, I think. Okay, locally we've been moving. Yeah, but I believe Dr. Ernest will give a very roadmap about where data science Africa come from and where we are going. So to me as beneficiary of data science Africa, I first heard about it when I was like any of you people here. So it came through my supervisors. It came through so around 2015 or 2014. So data science or AI was a new thing, a very new thing. Yeah, but I heard about it when I was starting my graduate studies. So what you call something small today that we've discussed here may be your lifetime thing. You may stick with it forever. So as a student, I got interest to know what I could do with AI. So then from masters I did some research on diagnosis, on understanding crops, understanding how we can detect diseases with the devices we have, smart devices. So that became my long-term project up to now. The research we are working on as a lab, as a group. So through data science, after my PhD, I managed to get two research grants. So I'm saying this that to tell you that data science has other opportunities, like research supporting right off from students who are even undergraduates, graduates, and also those who are early researchers. So you realize there are different types of travel grants. We always have gap in different countries. So I would say as students you have to alert sometimes. This information comes and then you miss it. But you're young, you can travel, you can network, and you never know where opportunities take you. So I was just saying that to alert you that this is the start, and then it's not like end. So interdisciplinary research. Now we know about AI and machine learning in all this concept of data science. So it can be applied in all different diverse areas. Health, agriculture, climate change, surveillance. Computer vision, robotics, like I've put them here. So it's always our initiative to know where do I what problems do I have around me that I need to solve. So if we ask any of us here, perhaps they have interest in different things. We have students of computer engineering, Busitema. They are major into robotics and IoT research. But the element and how you connect data and how you connect it to reality sometimes is a problem. So that's why the interdisciplinary research comes in. You may have expertise in real engineering, in software development. So usually these if you have a project and it has these different experts from different areas, it makes more sense. There are why we need interdisciplinary research, or why we need AI or machine learning in day-to-day life. It helps us in making decisions. If we are to gather information, you know that now information is everywhere, and we have a lot of it which we can't even exhaust all of it. So there are lots of information around us, and also every day there is every second there is millions of data happening everywhere in anything. So like I said, ML or AI has been used in many fields, health, diagnostics, crops, traffic, and other areas like you can see there. So this is one talk that yesterday by Rose. Rose has been doing. So I'm going to give some examples here that can relate to this what I'm trying to talk about. So Rose has been purposely working in the health sector with malaria diagnosis, and we can all remember and relate her talk how she's using AI to improve livelihood, to get data, to make use out of the data that she's getting from hospitals. So I will not go deep into her talk, but I can relate back. So myself have been working with crops, like I said. Became for now more than 8 years. So we've been investigating on monitoring. And we've achieved many things out of this. Yes, we can detect diseases using our smartphone. Yeah, we can look at severity of these diseases. We can even tell them to you. We can tell you that the disease is the crop has a disease even at about week 5, week 6 of infection. Yeah. So at the same time, been investigating on low-cost tools that could be used locally by people here. So we've investigated on how we can develop some of these here at the lab, and also with other labs, Makerere University. So that's one of them. And then we also engage in communities around us. Why are we in the East today? Why is it important for us? We know that most the vulnerable groups, people affected with food security. You enter someone's farm and you see that drought hit here. There is nothing. to harvest at the end of the day. And so these are the problems we need to investigate and look into problems of climate effects, crop disease, and but we cannot do this when we are seated here in our labs. We have to communities. We have to engage with different stakeholders. We have to understand these problems from the root. So more to that, I'll talk about other areas where this research is making more impact in our lives. We've Sandberg here in the University. They work on natural language processing, translation. The other day I was listening to someone. If you wanted to give your the person or your grandmother a tool or technology that is meaningful to her, what would you give her? What do you think they need most? Think about such people. Think about areas where translation and speech is really a problem. Some people can't hear or understand this language or the other. So there's a group doing a lot of work here for AI people to understand these things. So and then there are also other projects happening in the country or in the region. Led by AERCO. This is to do with air quality monitoring. Having sensors everywhere. Pollution has become a problem. Right now, I cannot walk out of my home even for 4 kilometers. Even if it's early in the morning, I cannot walk because the dust. You're already noticing that. So these some of the projects that are making impact in this globe. So if you are a student out there wondering what can I do with AI or data science. So millions of data can be gathered at this point. So for us it's very important to understand what projects you think are happening in your university or in your region, in your community. What can you do data science and AI? So this brings me to one important also a discussion. I don't think I want to talk like all those minutes alone. But I also want to engage you a little bit. So what do you think are those key influencing factors that affect research in your in this space, interdisciplinary? What is happening institution? What we getting doing all we need to do? Why do you think? Maybe we're already doing something. What are those factors that can impact or influence on interdisciplinary research? We can just debate about 5 minutes. If I missed out something here, then you can also or you need like a minute to study what I tried to put together. Yeah, but here we have whole institution. We have the economy. We have you have to think about capacity or communities, okay? and also the technical support that could be somewhere else. But the training, do we have enough training? Do we have enough training to tackle these problems? Do you think we have it in our institutions or our communities? Do you think our engagement strategies are enough? So these are some of the questions I want us to discuss as the next part is really questions. But I want to internalize some of what do you think is here, or what do you think we need to have this to improve on the way our research is happening in our institutions, and how we can also improve live communities. Any suggestions, questions, input? Okay. I'll take. We can take. We can take 5 minutes. So we can take 5 minutes before.
Thank you so much. Thank you so much. My name is Lilian Tamale. I'm a PhD student. Thank you so much. Thank you so much once again. Machine learning, artificial intelligence is a new discipline. And to me, it's so much helping communities. When I look at whatever's been talked about, the health, agriculture, the end users are the local people. I think one of the major issue is adopting this technology and finding the best way to explain these people. First of all, if I'm talking about machine learning to a farmer, or artificial intelligence to a local farmer, how best can they understand this? I'm thinking that is one of the major issue. Even looking at yesterday's presentations, there was a submission where a person confessed that maybe does not understand this. So if the educated are not really in the know, how will the end users or these other people understand it? I think it's one of the major challenge at the moment. But through training and having basic information or best way to really make people understand, I'm thinking we will get there. Thank you so much.
Yeah, so we are more getting suggestions, not questions at the moment, right? So it's suggestions. Then questions can come later on this part. Thank you, Lilian. So she thinks community and end users have to put in all this picture for this technology to make more sense. Okay, thank you.
Yes, good morning. Thank you, madam. My name is Isaac. I'm seeing your project for crop monitoring disease. Just like an inquiry about is it okay? I'm asking like a suggestion. Like is that thing having like a local language for these farmers to understand and also can be able to use your device, or are you the right person who is using the device? Can be monitoring for farmers, or those farmers can also for themselves using their local language. Because I don't think all people can know how to use this device in the English language. Thank you.
Yeah, that's an important question. Yes, about the tools we are working on. That's why I hinted on translation. So we aim to have tools that our locals can really use very well. So there is an element of translation. Someone can also use audio and to get a solution or to get an answer of what they're looking for. So we are having all this. If I talk technically, we are having a whole combination or multimodal approach where a farmer may take an image or one decide to use audio, one decide they don't understand the language. So all this translation and all this modeling is happening into our end user tool. Thank you.
Thank you so much, Isaac. One of the topics I want to talk about AI and how it is going to impact in our community. I will base on something like collaboration, especially in the university students. Like
Is it possible for us to deliver those models free of charge to the local users, as in kind of motivating them to use them? Maybe we even go through the government, we make it like a government project such that people can easily adopt the projects. Thank you.
Good morning, everyone. I'm Dr. Viola from Chambogo University. I'm also in that field of data management, which has new concepts of data science, big data, and so forth. I'm looking at one of the factors for that influencing this research of artificial intelligence is data sharing is really a challenge within all stakeholders in these systems. So I'm suggesting if we can come up with a strategy which can really motivate these stakeholders on how to share data. Thank you.
Thank you very much, but I would like to expound what I had almost the same idea like from the previous speaker, to integrate stakeholders into AI. And I think I want to be specific on which particular stakeholders. Someone has talked about government, but we also do this for money, for growing, for making our lives better. So when the researchers do all this data and everything, I think they should bring in entrepreneurs, people who will market, put the thing on, like integrate the entrepreneurs into the whole thing, because to do all this research we need the money, but also we also need to make the money, and we also need to grow the economy, because AI should have a great impact on our economy and the country at large. So I think the way we have had this integration within the academia world, somehow maybe we can also find ways of integrating it with the entire entrepreneurship fraternity.
Yes, I agree with everyone. Actually, everyone. I agree with everyone. So money is the thing. We also need money. We need to grow our economies. You know, the top AI companies at the moment, you know. So they are making a lot of money from us. We are giving them all the data, and still, at the end of that, but still also we are a developing country or developing countries. So sometimes when we are trying to develop these tools, well, you can put in something, especially if your tool is widely used. And look at mobile money, people who invented that. M-Pesa, you've heard what on the other side of the region where Kenya is going with the M-Pesa technologies and the likes of that. So some technologies will really help you get more money from this, but then also like another person said, government or other stakeholders or policies, they can influence so much on how this uptake of these technologies can look like. So I think this is a very whole open thing. Open data source and data sharing is a very key thing. But also there is also always another debate on this data that we share. Is it safe? Is it, you know, have people consented? Do you just take data from, you know? So there should be some consent, and also people should know that you're taking data from them. I think that is also important. So this is a whole discussion, and I leave it to you, to our institutions, to government, and all other stakeholders. And I don't think I have anything more to talk about, but to thank everyone who is here, to thank all the stakeholders. I think others could be missing at the moment, but thank everyone who has supported this, and seeing all these big numbers here is not, we don't take it for granted. And then to thank you for listening in, and also all my organizing committees. Thank you very much. Lilian, what do you have to say?
Thank you, Dr. Godliver, for sharing your inspiring journey in data science research with us. Sometimes I see rounds of memes on social media. Somebody shares some information and they say something that I don't remember the exact words, but they normally say you can do whatever you want with the information. What do they say? Use the information the way you want. So Dr. Godliver has informed us of the various opportunities that data science Africa. It's a community, we now know from her keynote speech, that it's a community that is committed to mentoring and growing researchers in data science. So let us use this information the way. So Doctor has answered all our questions, and the emphasis on multidisciplinary research has come out strongly. Yesterday was filled with great insights, learning and networking, and as you heard from Dr. Godliver in her welcome remarks, today promises to be equally engaging and informative, with exciting sessions and speakers lined up. So let's make the most out of today. Let's share knowledge, build connections and network as we wait for the Vice Chancellor to officially inaugurate the workshop. I'm optimistic that multidisciplinary research groups will come out of the networking that we are doing in this workshop. So the people who have posters and would like to just tell us maybe briefly about their posters are welcome. Research idea, this is a great place to throw your idea out there and receive positive input. It's very rare that you find all these experts in one place. So this is an opportunity that we should not overlook. Okay, thank you.
Thank you. I would like to make use of the opportunity because I'm going to, at the closing session, present a research proposal of research that I'm planning to do in the upcoming months, actually as part of one of Godliver's projects about the echo diagnosis tool, which is an AI tool for farmers to use with a smartphone to detect or diagnose plant diseases or
Good morning once again. I'm very happy for this platform. I'm a PhD student, and my question is, with data science, we tend to use data sets, but we are sometimes told to go to the field. My question is, if I go to the field and identify an attribute or a variable that what tools, e.g., you need to employ to get these data sets, and maybe whom you need to collaborate with to help you as a student. Because as a student, there is stress, you want to see things out. Yeah, but I think partnerships and reaching out to different stakeholders, companies, I don't know if you're working in the telecom industry or maybe reaching MTN or other telecom companies. I'm just giving an example. Could help. So, however, you can also, depending on the timeline, you can also build your own sensors. Maybe in agriculture or climate change or something, you can also build some sensors, like what our students are doing here. So really, this varies a very broad question, but I think you get an element. Yeah, so thank you.
Thank you for asking, Dr. Bodima, for responding to the query. Any more questions?
Good morning to you all. I'm Joey Busitema from Chamber University. My question goes to the Data Science Africa organization. I think it's an organization. So we have been talking about data science. Some presenter was reading out some Python code. So my inquiry was, I happen to come from Chamber University, and we have an association. It's called Chamber University Computing Students Association. So I don't know, have you come up with structures like to bring up teaching this other young generation? Because mainly I'm hearing doctors. So even else would love to be there. So I don't know whether that initiative is there to help us, for us who are still undergraduate students. Thank you.
Dr. Ernest,
even thought of coming up with some type of content, like content that you can share if you go back, like all these things we've been presenting, you can present to your colleagues. But mostly the idea is to build a community. So now that you're here, now you know Godliver, Dr. Godliver, you know so many other people here. And this is important. This is almost more important than the technical things. Yeah. So because, as they say, you're the leaders of tomorrow. They keep saying this, but Anyway, but you're the leaders of tomorrow. You guys are going to be the ones doing these things. The world is changing quite fast. But I think what we've seen in the 8 years we've been doing data science, these data science events, many people have benefited from these connections. You meet someone here, you meet a professor here, there's a research visit, you go on, you do a really good project, there's someone who knows about funding, it gets funded. So there's a lot of community help that this gives, even just learning. Also, just an announcement, there's PyCon happening, I think, today and tomorrow, Saturday. So I hope those communities are plugged in. PyCon, I think, will be a very big thing. It's unfortunate that we had to clash with that, but that's just a big thing. Yeah.
Thank you, Doctor. And from what I heard from Dr. Godliver's speech, she did not join Data Science Africa as a doctor. She became a doctor when she was already in. So it's not a doctor's affair. I saw a hand here. There was another microphone moving around.
Yes, Doctor. For me, it's not a question. I'm just responding to a student who talked about what to do in case she realizes that she has identified a certain data type from the field. What can she do? My response is, or my suggestion is, she has to liaise, of course, with her supervisor, and she has to justify how important is that data type to her research or to her research question. Thank you.
Thank you for answering her question. There's somebody over there. Okay, everyone will ask. Everyone will ask.
Yes, thank you so much, Dr. Andima Moses. I'm coming from a different angle from chemistry and want to see how we apply chemistry to develop drugs. And so in Busitema University, we have a Natural Products Research and Innovation Center. And in Uganda, we have so many herbal products. And our herbalists can claim that one herbal extract can cure so many diseases. So what we're trying to do is to see if we can have a platform where we can screen these herbal extracts. But then the challenge that we have is we do not have all this sophisticated equipment like the mass specs, which are so expensive. And with our systems, it's really difficult to maintain them. And so what we do is we generate a lot of data. For example, if you just have one extract, you run it using, for example, a liquid chromatography mass spec, you generate a lot of this data. And so we will be glad to have teams that can collaborate with us to develop a platform that we can use to analyze these herbal products so that we can standardize some of the herbal products that we get in our market. This has been a nice platform for me to learn lots of things. Personally, I do not know how to do Python, but I'm trying to learn it. Hopefully, I will be there in some months to come. But we'll be happy to have people who can collaborate with us to see how we can develop platforms that we can be able to use. For example, we can run assays, several assays, but then you have to keep repeating these assays. So is it possible that I do this assay and then we train a system that if you do this assay another time, it's easy to replicate it? Or, for example, is it easy to know how a particular drug acts? So can we be able to look at these different gene sets and see how these different extracts can actually interact with the different disease targets? Yeah, that is our focus, and we'll be happy to have teams to work with us. Thank you.
A call for collaboration there. That is nice.
Yes. Yes, good morning, everyone. I'm called Taban from Muni. I just want to share some, I'm not sharing, but just to inform that at the university we already are having masters in AI for members to get to know, and we have also a community, AI community. So it's a very good platform and a high chance to learn that this Data Science Africa is very important, and we are learning a lot, and we as the stakeholders to collaborate and see that the next AI maybe will be happening in Muni University. And I thank the members, the team, that we shall always be together. Just for the students who are interested in AI, we have masters enrolled this year. So far we have 18 students doing AI. I think some of them are attending online also, and we have one colleague who is with us. Thank you very much for listening.
Thank you, Dr. Taban. So Dr. Taban has started a campaign to bring the next Data Science Africa to Muni University. Dr. Taban is the head of department, the Department of Computer and Information Science, the Faculty of Techno Science at Muni University. So Dr. Taban will soon be asking for votes. So please rally behind him. I'm trying to remain impartial, but but do we have anyone who, okay, there's someone with a question?
All right, thank you everyone. My name is Sevagara Douglas. I'm from the private sector. I'm a project lead with the Wikimedia Community User Group in Uganda. So I have like 4 comments to share, and those would relate to an idea. We were asked to share ideas and also maybe sharing some opportunities. So the first one is about languages. Yesterday I briefly shared this with Dr. Ernest Mwebaze, and it's very interesting. Last week I learned that there are over 200 languages in Nigeria, but that was not a surprise, because there was also a bigger surprise that in Ghana there are over 520 languages. So linking this to the relevance of our context, in Uganda, I don't know if you know how many languages we have, but good enough we have a starting point to see that we are using AI to bring out such content in our locality. So one of the things that we work with at Wikimedia Uganda is developing the Luganda Wikipedia. It involves translating articles from the English language to the Luganda Wikipedia, and also building new content for the Luganda Wikipedia. So it will be interesting to link up and see how we can be able to build these tools and also this platform together with the Ugandan community. We are already collaborating with some Luganda teachers, and we have a community for Luganda Wikimedians who are updating this content. So that is the first thing I wanted to share. The second thing is about content and free knowledge. Most of us know about Wikipedia, but above Wikipedia there's an organization called Wikimedia, which has quite a number of projects. that revolve around free knowledge. So I wanted to see if we can be able to use AI or data science to leverage innovations or new ideas around content on information and knowledge, free knowledge, basically. So this is also something that I would like to open up to everyone, because we are already doing it by organizing a small project. It's called WikiGap, to fill the gender gap, and we've done it at Busitema, and we've done at Mbarara University, Gulu, and also Makerere, working with the gender department. So I would like to say that we can be able to maybe see how we can collaborate and partner to create innovations and new projects. Then the third one is actually linked to partnerships, what you mentioned. So before I ventured into Wikimedia, there's always OpenStreetMap. Mappers are doing quite a number of things that involve remote sensing, data collection and analysis. So it would be good if we can be able to create these partnerships and see how we can move forward, since Data Science Africa, Data Science Uganda is in place and can be able to provide a platform for such innovations to happen. Then the last one is on opportunities. So Dr. Kodliver mentioned what DSA is all about, but additionally, it's about opportunities, because I'm also on the mailing list for DSA Uganda, and there was one of the opportunities that was shared was from Mozilla Technology Fund. I think there's a call for grant applications. So if there are maybe some people who might be willing or who want to give it a shot, I'll be happy to collaborate with them, and they can reach out to me or even like share on the mailing list so that we can link up and maybe try to prepare something. Thank you so much.
That is very important. I hope members, you're taking note, especially students. There is a great opportunity that has just been announced just a few seconds ago. Please get in touch and collaborate.
Okay, good morning, everyone. I'm called Leonard Nkalubo. I'm a lecturer at Chambogo University, and I'm a fourth-year student at Makerere. I've already submitted in my draft PhD thesis, and I wanted to make a contribution here, especially regarding people who are collecting data. If you are collecting data from various areas and you have worked on your data sets, usually it is not very easy to get all the data that you want, because of money, because of space and time complexity and things like that. My area is looking at various models and then carrying out optimized models. Most of you should be maybe knowing what we call ensemble modeling, whereby you have 2 or 3 models. Like, for example, I'm looking at first stage models. An example is like YOLO, you look once algorithm. This is a very fast model for online fast carrying out detection. And then I'm also looking at second stage models, which are actually slow but are very efficient in they are efficient in terms of detection. So then you carry out what we call you combine them. You combine them together so that to ensure that you have like an ensemble. What you can't do when you don't have data, you can transfer. There is what we call transfer learning. Transfer learning is a process whereby you can get some of what you don't have within another model, and then you relate it and take it into another model, and you have another optimized model. So for those who can't get data from your research, use ensemble. You can ensemble or build, because what you can't get from one of the layers, like if you're using deep learning in RCNN or whatever it is, you can't train all the layers. So what you do, you get some of the capabilities within one of the models, then you transfer it to another model, and then you ensemble. That's very important, and I recommend all those who are doing research, if you can't have enough data, all you have to do is to use transfer learning. Then at Chambogo University, we have a new department, data science and artificial intelligence. So those of you who are here and you are younger researchers, you want to join, you want to get involved into data science and AI, I think this is an opportunity. We have developed programs, but we haven't launched them, we haven't called students. So use this opportunity to train quickly, to develop yourself, to interact with some of us who are here. There are so many aspects, there are so many opportunities for joining in to teach, to do research. And as you know, Chambogo is the second biggest university in the school in the country. We have we are in the center of the city. Please use this time to ensure that you interact with us. Thank you.
Thank you very much, Dr. Lenin Kalubo. Now the Vice Chancellor is ready to come. So we shall continue this session after the Vice Chancellor has officially inaugurated the workshop.
Thank you, participants. Good morning to you all. Good morning once again. Can we have some bit of energy? Good morning to you all. Yes. At least we need just a refresher. Can we all stand up for a minute? Just a minute. Yes. We've listened to so many participants here, presenters. Stretch a bit. Stretching is healthy. Turn to your neighbor and say hello. For sure, I didn't ask you to give them a hug, but if a hug is necessary, do that. Just a hi, isn't it? Yes. Just a hi. I would love to thank you for that, and I request kindly you sit down, resume your seats. And as we go on with the next program, yes. So I just want to thank all of you for being patient with us and for the active participation you've exhibited. And we thank you so much for indeed a very generous aspect as far as your participation is concerned. I'm very sure mentions have been done, and we are familiar with some of the participants here. But I wish to go on by welcoming all those key officers who are around. The Director of Graduate Studies, Research and Innovation of the University, once again, Associate Professor Samson Wawire. I request you stand up and wave to us. He's at the back there, and directly this engagement is in line with his mandate. I'm sure the Deputy Dean of this faculty, Professor Nibikola, is with us here. Doctor, you are most welcome. Wave to us. In this university, we have people who handle matters of chemistry beyond chemistry. Dr. Andima Moses is here with us. Can you wave to us? You are most welcome. Library is well represented. A representative of the University Librarian, can you wave to us? Yes. And all other key university officers, they are here to ensure that you are all comfortable in this room. Colleagues, join me to welcome the Vice Chancellor of this university who has just arrived and has logged in, Professor Paul Wako. Professor, you are most welcome. We can't take this for granted. Also, your minute and time you are going to spare with us here, it is worthwhile. We want to thank the chief host. You see, Busitema is hosting. Now we have a chief host. The person who has been on ground here organizing this very historical event, that is Dr. Godliver Owomugisha. Dr. Godliver, you are most welcome. I know you've welcomed people. Now I'm welcoming you on behalf of the entire university, isn't it? Yes, and she will be able formally, before the Vice Chancellor, invite her formally here to welcome all critical visitors here in the next few seconds. But I can't put this microphone down without welcoming the manager of Stanbic Bank Tororo branch, Mr. Polot Simon. Members, Stanbic Bank Tororo and generally Stanbic Bank, they have been our key partners in all university events here. So we want to give them another round of applause for the wonderful job well done. Without wasting time, I'm going to invite Dr. Godliver to formally bring in a few introductions of key critical visitors we have here. All of you are visitors, isn't it? I've done some mentions. I know she will not repeat them, but there are those whom the Vice Chancellor needs to jot down and even take special recognition. Please, Dr. Godliver, kindly come and introduce our visitors formally to the Vice Chancellor, and at the same time, you will use that very moment to invite the Vice Chancellor to address this congregation.
Thank you, Dr. Mwesi, for the warm welcome and remarks. I welcome you once again to Busitema University, and I would like to welcome our Vice Chancellor, Professor Paul Wako, for coming to officially open our event. So we've been here for one day, this is the second day now, and we are a team of so many people from different places. So I'll mention here we have Busitema University, we are hosting. We have Makerere University, please wave if nice. We have Chambogo University, yes. We have Muni University. We have Soroti University that has been led by the DVC Professor Choshabe Florence. You can stand up for recognition. Oh, thank you. Okay, yes. So we also have people from industry. Before I go to industry, we have IU University. Yes. Any other university I've left behind? Eastbat, yes. Eastbat University. And Barara University. Kabale University. And yes. So we have other members from industry. We have Stanbic Bank. We have Mr. Kato Dixon. Yes. And Manager Mr. Samson. Then we have other stakeholders like Sunbird AI with the CEO, Dr. Ernest Melaze, seated next to you. We have students from University of Twente who are visiting. I think we still have other members. In case I've left out any other person, please inform me. Yeah, so we also have this event has been sponsored by UN Global Pulse Lab, Data Science Africa. We have, I said, Sunbird AI. We've also been in partnership with members from GIZ. We have, I forgot to talk about URL. we have representatives from URL. So it's really a whole big community here. And Mr. Vice Chancellor, I would like to say we've had a very good engagement yesterday and today. So I will invite you to officially talk to us and at least to know everyone who is here, and then we can listen to you and also go on with other presentations of the day. Thank you so much.
Thank you very much, Dr. Godlive Owomugisha, not for inviting me, but for consistently talking about data science at this institution. My name is Paul Owako. I'm a professor of pharmacology and therapeutics, serving an administrative role in the university as Vice Chancellor. I'm here to welcome all of you to Busitema University. I've particularly been informed that we have teams here from Makerere, Soroti University, Chambogo, Muni, Kavale, Isbat, IUIU, and many others. You are welcome to Busitema. We are a bit up country, but there is fresh air here. Those of you from Kampala must be enjoying the fresh air. You know, I worked in Kampala for a long time. I was in Makerere from 1995 up to 2013, when I left to join Busitema University as Dean Faculty of Health Sciences. And I experienced the change which you are going through now. And after seeing the fresh air in Busitema, I never wanted to go back. So I remained here. So allow me warmly welcome all of you to this data conference. Owomugisha and your team, thank you for the invitation. And I thank Data Science Africa for choosing Busitema University to host this conference. Busitema University is a multi-campus. What you are seeing here is a sixth of what Busitema University is. You might go away thinking Busitema University is this small, what you have seen. But Busitema University geographically is one of the biggest universities in the country. Because where you are is the Faculty of Engineering and Technology, and we have here just about 800 students doing various programs. Get interested in those programs. Some of them you've never seen them at your universities. I don't think there is mining in Makerere. I don't think there is textile engineering I know it is in Chambogo, and many other degrees, agro-process. You don't make a company which gave you the reagents one of the authors of your publication about the world. Now, this is the story about how we should be handling this new oil. And it raises concerns as to how much capacity we should put in data. When we were in Rwanda, that was in May, as Vice Chancellors in the Eastern African region, under the auspices of the Inter-University Council for East Africa, we agreed that every training institution must go back and institute from various parts of the globe. I've already talked about the team from Twente University, and next, start small, but I know we shall be there, and indeed we have no choice but to walk the journey of institutionalizing, building capacity to ensure that we utilize data. With those few remarks, allow me to thank the organizers. You can't hear me? Yes, allow me to thank the organizers for the work you have been able to do to put in place this conference, and those who are from, I don't know if there are some visits after the conference, usually take time to learn about Busitema University. Some campuses are far from here, but I hope you can learn something by touring around. I once again warmly welcome you and thank you for accepting to participate in this conference. I wish you good deliberations. Thank you very much.
Thank you very much, the Vice Chancellor. A round of applause to the Vice Chancellor. And I'm sure the message has been well received. We thank you for being attentive. And Mr. Vice Chancellor, before you go, I'm going to ask for some 5 to 7 minutes of yours. You listen to one of the presenters whom I've selected carefully, and that is Mr. Ernest Tumwebaze. At least one speaker. Then after, we shall be going for group photo, all of us, the participants of this workshop. Then after we proceed for break. Will it be break or breakfast in that sense? It will be lunch, mini lunch, whatever the case. Can I take this opportunity to invite Mr. Ernest Tumwebaze? At least 5 to 7 minutes. Is that enough? Yes. Thank you.
Great. So the Vice Chancellor of Busitema University, Professor Paul Wako, the heads of department and management of Busitema University. I think we have management and lecturers from other universities here, the public, the private sector, Stanbic Bank, and all the rest. Ladies and gentlemen, good morning once again. So I just want to talk very briefly about Data Science Africa. So we are really a grassroots capacity building organization. I think this is what, it aligns very well with what the Vice Chancellor talked about. So we are interested in building capacity in local institutions, in universities, but that target the grassroots. And Data Science Africa runs what we call summer schools and workshops all over Africa. This is the core goal of Data Science Africa, right? And in these summer schools and workshops, we teach theory and practice of data science and machine learning, and the use of data to improve livelihoods. This is the core of Data Science Africa. We started in 2015, more or less. We've had 11 events through 8 countries. The most recent was this year in Rwanda. And again, we had participants from all over the country. We've had events in Nigeria, in Kenya, in Tanzania, in Rwanda, in soon to be Senegal, in South Africa, and Uganda, of course. These are some of the pictures from very earlier on, some of the events we've had. Every time we go to a place, we want to take a good picture, and hopefully after this we can take one from Busitema University. What are the core tenets of Data Science Africa? So this, what is in our blood? What is the spirit of Data Science Africa? So one is by Africa. So we are very keen that data science is led by Africa, Africans, that we deal with African institutions. This is very important to build our own brand. I think the Vice Chancellor talked about owning our data and making sure we control our data. This is one of the key things. 2, student focus. So as Godliver highlighted, there are very many students here from different universities. We are very interested in students, building the capacity, because this is how we build our nation. And we are about solutions. So the third thing is about solutions, and we call this end-to-end data science. So you don't want to teach only theory, but want to teach solutions, so that you come from here, you go to your fields, to your neighborhoods, and you positively influence that. And we are very glad that the Busitema University AI and Interdisciplinary Lab, led by Godliver, is doing a lot of good in this area. The fourth is that we are about sustainability, inclusivity. So the way we structure these events is, want them to be highly sustainable. So On that note, we definitely thank the university for hosting us here. We are very glad, Vice Chancellor, that you managed to give us all these facilities for free. We are very excited, and this makes Data Science Africa sustainable. And about agility, agility is about the ability to pivot, to move with the changing winds. We have a board, an eminent board of people from Uganda, Kenya, Nigeria, and we have a board of advisors. This is Professor Neil Lawrence from Cambridge, John Quinn, who's in Google, and Lane, who's in Boston University. So these are people who have been intimately involved with Data Science Africa since its beginning. Student focus, end-to-end data science. So we are really keen on solutions. So the first image there is of a cow where we put a sensor. So the idea, I think this was in Kenya. And we're trying to track the movement of the cow. Then you can predict things like, is it diseased? What are these patterns of movement? It is here, and here the students were putting sensors on these animals. So they had to build a sensor, put on the animal, and then connect to a system that can monitor the cow. Here, the picture in the middle of students in a conservancy trying to monitor birds, bird sounds. So they mount different sensors with cameras, and they take images, or they record bird sounds, and then you can try to understand the acoustic environment in a conservancy. The third picture here is sensors monitoring greenhouse crops. I think this was a greenhouse, and we're trying to monitor the temperature, the humidity, soil fertility, and this is automatically transmitted. So all these projects, the students in the summer school go out, they create the sensors, program them, deploy them, go back to the lab, get the data, and from the data they can start doing inference, right? So by the time they leave the summer school after 1 week, they have they've attempted to solve a real life problem, and they also they can sort of transfer that knowledge to where they're going. The cassava story this is a very common story. I think Godliver has done a lot of work here, so I'll not go into that, but I think what we are seeing is that, they're out in the field dealing with farmers, and this is very important for data science. This is what is in our spirit. There are many opportunities for students for growth and experience. We've had several student visits across the countries. Data science has supported this. It supports mentors and peer learning. We've had a data science visiting fellowship. So we got some funding to support fellowships to visit, professors. I think we had a visit in University of Cambridge. I think the website now has more opportunities, so students who want to take advantage of these opportunities can harness them. And we've had the DSA Research Award. Dr. Godliver has benefited from this to enhance the work she's already doing. This award is coming up again, so if you have projects that you're doing, we want to support students who are doing good work, we want to support the ecosystem here. We have local chapters. So local chapters is a new thing. So this is the first time. So this event actually is the very first event of a local chapter. So Data Science Africa is Africa-wide. Data Science Africa Uganda chapter is a local chapter in Uganda. And the local community of Busitema University AI Interdisciplinary Research Group, which is around here, is a local chapter, a local community in the local chapter. And so we're very excited to hold this event here. This is the first of its kind in Data Science Africa. So we are very pleased that you are able to host us, Mr. VC. And we collaborate with very many affiliated centers, and there's so many activities that we're trying to do. And we have several sponsors. Data science is gladly supported by very many people, both here and outside. So I'd like to stop there and thank you all, and specifically thank Busitema University and the management for hosting us here. Thank you very much.
Mr. Mwebaze Ernest, we want to thank you so much for that preamble. For us from the humanity backgrounds, I'm learning a lot about data. And I think this is an opportunity for many of us who are like West here to learn more about things, how things are done, especially matters of data and so on. So I want to thank this opportunity given to us by the organizers. And unless if there is anything to pass on to the Vice Chancellor, I want to request him, together with Dr. Gottlieb and your delegation, to step aside, and we shall follow you so that we take that group photo. All of us, we need to be part of this historical photo moment. Please join the Vice Chancellor just outside this very hall. That's where we usually take our photos from. And the people concerned, especially paparazzis, do the needful to assemble there. I would even request Dr. Gottlieb to use that moment to introduce some of the heads of delegations from other universities to the Vice Chancellor. So all of us, let us move out and we take part in that group photo. And immediately after the photo, we shall be led by the very team to have our mini lunch. We agreed, not breakfast for that case. Still lunch will come, dinner will be here, and what else for tomorrow? Anything. So we thank you so much for being active. Let us join that group photo as we progress with the day's program. Thank you so much, all of you, for your kind attention.
What makes Busitema University unique is its identity, which we established right from the very beginning. It has unique academic programs. We did not reinvent the wheel. We scanned the environment and identified programs that are relevant to the development of our country.
Highly recognized and awarded, Professor Mary Okwakol, a transformative leader and the founding Vice-Chancellor of Busitema University, is a lady of many firsts in her life. She is the first woman Vice-Chancellor of a public university in Uganda, the pioneer Vice-Chancellor of Busitema University, the pioneer Deputy Vice-Chancellor of Gulu University, the first woman Professor of Zoology at Makerere University, and many more. Her vision and strength saw the birth of Busitema, a Ugandan multi-campus public university established in 2007. The university vision is a center of academic and professional excellence in science, technology, and innovation, while the mission to provide high-standard training, engage in quality research and outreach for social-economic transformation and sustainable development.
It is unique in that it is a multi-campus university located in rural areas of the country, unlike the big universities like Makerere, Kyambogo, which are in the capital city. By virtue of its location, Busitema University has extremely high potential to impact on rural communities.
With multiple international partner universities,
The what? Put up your hands and I just choose you. Yes? That it has a bottle top. Good. So if you say, does it have a bottle top or not? Yes, they will say, yeah, we have bottle tops. But will it be really relevant data? Yes? I think when he said labels, he just meant the wordings. That there's a word here, nirvana. Because if you can recognize the texts, the characters, then you can say that you have to look for nirvana or renzori. Let me see if this one has some. Yes, it has the word renzori. That's what I think he meant, if I'm not mistaken. But then if you meant what he's saying, then it will be data, irrelevant data which you're going to collect, disturb people filling in those questionnaires. Your research assistants will be disturbing themselves. They bring that data, and then it will not be what? So, a distinguishing feature should be able to uniquely identify your class or your object. If you can think of it early, then you just go for that data. And, for example, how you can, the condition it is in. These accompanying narratives are very good. Like those movies, those ones who are doing AI in movies. I don't know if we have any researchers of AI in movies here. If you're doing something in videos, video editing, you'll have to identify a movie by probably things like their producers, the year it was produced, what other things. Those are accompanying narratives. Even if it's a series, you say maybe this is episode 1, which series 1, is something like that. So those ones are captions accompanying information, which is also very good. So where do we get our data from? Most of us, we shall use the available data sets. Data from Africa, unfortunately, is not common. Unfortunately, we have remained consumers of other people's data. You find that we are using online data sets like Cargo or GitHub. You ask yourself, how often are you contributing that data to those platforms? And you find that Africa, we contribute less than 1% of the data. Is that really representative of our brains and our potential? Is it true that us in Africa, we cannot really create our own data and share it? Is it really? Yeah, I was on Cargo yesterday and I saw the analysts working in the cassava disease identification, and I was happy. I've also put the sickle cell one, I've also uploaded it there. But then, if you must, then you really need to create your own data sets, because there are some variations. Are you seeing now like maize? You will find that maize, the way our maize looks like here in Uganda, may be different from the way the maize looks like in Kenya, in the gardens. You take a photo of it and it will be, it's all maize, yes, but then there may be some subtle variations just because of our climate or anything, any other reasons. So, when we are developing our data, we need to be aware that all our data, either if it is text, or if it is images, or if it is videos, has to ultimately be converted into numbers. Here, we are seeing an image of a sickle cell of red blood cells. And if you can see if you can be a little bit more observant, unfortunately it's not so clear, but you will see some of, like this one here is a sickle cell. The others are normal red blood cells. Now this is an image, it can be the input image, but you should be able to convert it and to look like this. Like in our case, in the current research which we are doing, we are just using 3 attributes, that is area. This image had 29 components. Those balls, we had 29 which we got. We said, okay, let us look at the area, we look at the eccentricity, and we look at the circularity of that component. Now all these attributes have to have, there's a formula you'll use to come up with this figure. And the good thing, most of those formulas are already available. Others, you'll develop them yourselves, but maybe for the PhD students, I know I've had a PhD student among us. For the PhD students, they may come up with their own metrics, which can be able to describe their attributes. For example, he mentioned size. Now, how would you define size? We have our two bottles. We are saying that one of the distinguishing features is size. There's a formula for size. Or volume. You may say that, okay, let's adopt the formula for volume. So you have to get the length times width times height. This is a cylinder. I don't know what is the formula. Pi r squared h, blah, blah, blah. So you identify the proper formula. Now, if you choose the formula which is not as good, you will definitely get wrong results, which are not as good. And one thing which I always tell my students is, when you're doing AI research, you will reach a point whereby you have to come up with your own formulae, which will properly represent what you want. Are we together? Because now, someone may say that the size is just the length times the width. Someone may say that. Area. He may say, let size be represented by area. Another person will say, no, let size be represented by volume. Another person will say, let size be represented by number of pixels, if it's an image, number of pixels. Another person will say, let size be represented by anything you want. As long as you can get it into a formula, you're good to go. So, I know that some of the students here are totally green in AI. They've never seen what data looks like, which is used in artificial intelligence or in machine learning. It looks like this. Just rows and columns. Nothing much. Whereby each row will represent an instance of that object. If we are going to know the classes of the mineral waters, we shall say, okay, there's one mineral water bottle which we have picked from here, and this is instance number 1. Then you do what? You get the parameters which you have agreed to. You go and you pick another bottle from somewhere else, maybe from another room, and then you also say instance number 2, this one is these are our parameters. Now, you must have another column for class. In this class, how many classes do we have in this data? 2. Yes. We have only 2 classes, 1 and 0. Meaning either 1 is going to mean class 1 or class 2. You're free to have as many classes as you want. In this case, we shall only have 2. Class 1 for Nirvana, class 2 for Renzoro. But then the other mineral water bottles, is there any other mineral water bottle here which is different from these 2? We don't have. But then which other brands of water are there? Shiba. You can have another brand of Shiba, another brand of, which is other singer, also see her on one of those water. Spice. You can have also that brand is there. So we shall now be having now 4 classes of what? Of water. So AI data, the columns represent the attributes or features or parameters which are talking about our instance. So you can have as many rows as you want, the more the better. But the format you're going to save it in will need to be tab delimited, and the common ones are the .csv and .txt. So if you have your data in Excel, you will have to save it as one of those two. So when you get your data, you must clean it. If you use it without cleaning it, you may get errors. Now, this is an example. If you just look at the screen, I went to Google. I said, can I have photos of bean leaves? Now, these are examples of what came out. This one is just one leaf. You can see it is good, looks nice, clear. This one has very many bean leaves. That one has different colors. The other one has. So when you're inputting in your data, looking for a data set for leaves, bean leaves, you'll get very many types, very many formats, sizes, you know. So one of the things that you need to do is to clean the data. What does cleaning mean? It means you're going to kind of pre-process the data, filter it out, say that this data is okay, this data, let us not use it. These spaces which are here, do we just put in zeros? Because you can have some data and all the data is in, that's good. But suppose you get an instance whereby they did not calculate for you the size. It is empty. What do you do with that data? You'll decide. Am I going to remove it from the data set? Or am I going to fill it with a 0, 0, 0, 0 or 1, 1, 1? You'll decide. That is what we call data cleaning. Then, we shall also need to identify the region of interest. These images you see here, the first one is a sickle cell image, which has the red blood cells. We have said that that is so much information. Color red, color white, color pink, color purple, black. So this is because it's a color image. Those ones who know images, you know that an image, an M by N image pixels, will amount to an M by N matrix, isn't it? If your image is 500 by 200 pixels, it means each of those pixel values have values. So it means that image is going to have 500 times 200. How much is that? 10,000 values in the array. That's too much data. If you're going to have 1 million images, you run your code and you'll just sleep there waiting for you to give you back results. So what you need to do is you need to simplify it to something like this. Now, if you simplify something like this, you will find that your array will probably reduce, instead of 10,000 array to represent the image, it may maybe have only around 1,000. So those are some of the ways in which we can say that we are pre-processing our data. Removing noise. Noise is that data which is just confusing us. It is too much for nothing. Remove it. Like what we said, if someone has decided to capture color of the bottle. I have not yet seen a mineral water bottle which is not transparent. Have you seen water in a bottle which is maybe color green, color brown? Okay. If you have seen it, then the color of the bottle is relevant. If not, then it is noise. Removing outliers. You may have data and you want to visualize it, but then your graph is squeezed in front here, and because there's one particular point at the end, just ignore that point, remove it out, have a very good visualization. Now, another thing which you can do as we are preparing our data is to normalize the data. Yesterday, I saw the other student, he was presenting work on housing, and he showed us some graphs here of some places, their latitude and their longitude. It seems it is a rich suburb. You know? How would they know if it's a rich suburb? it means there's money involved. Probably they asked people, can you tell us your yearly income? Now, yearly income is going to be in millions, isn't it? That is one row, yearly income. And no one column. Another column maybe can be age. Your age is usually we're below 100 years old. So you'll find that those values will be between 0 and 100. Another column will have data in points between 0 and 1. Another column will have data in negatives and positives. Now that data, if you leave it as it is, you may get wrong information. It may be telling you that this one of millions is more important than this one of points. Are we together? A difference, let us say someone is getting 1 million shillings. Another person is getting 1,100,000. So there's a difference of 100,000, isn't it? It may be actually small, that difference of 100,000, because there's another person who's getting 200,000. Now, 100,000 difference vis-a-vis another column which has a difference of 1. Let us say age. Someone's age is 36, another person is 35. Only a difference of 1. If you leave it like that, it will appear as if this other column of 1 million, of millions, is more important. It will actually contribute more. Because what you're saying is that that variable is more important than the others. So one thing you need to do is to normalize the data. And by saying that, let the data have a common scale. These millions, we can be able to rewrite them so that the maximum it can have is 1 or 100. That's percentages. If you change everything and say, well, let's just be in percentage, it means the highest it can get is now 100. It will now tally with this other age, the other column for age, whereby also the maximum is around 100. Now that is data which is showing that these variables are equal. Another thing you can do is to convert it to a scale from 0 to 1. Then you say that this data is there, but we're going to convert it into points, decimals, maximum being 1. There are many ways, many formulas you can use to do these things. Another one is clipping or rounding off, like those outliers. What do you do for those outliers? Are you really going to not use them at all? Aren't you going to lose some information, especially if it is small data? If it is small data, you will feel bad to really ignore a certain instance just because it is an outlier. So how do we bring in the outliers to be part of the data? You can say, let me round off. You can say that let the maximum amount which can be put in here, if it's above this amount, let it just round it off to this amount. So that the data is there, these other columns can be used, and you can be able still to use the data well. So this is what they call normalization, and which also you need to think about when you're preparing your data. Then, splitting of data. We've heard us talking about training data, testing data, validation data. So how are you going to split that data? Because the training set, if you have your whole data set, you have to split it into at least 2. The training set, saying that, okay, these ones are going to be used for training, these ones are going to be used for testing, these other ones for validation, which is optional. But how are you going to do that splitting? Are you going to use a random splitting? Or are you going to use a purposive splitting? That one, it is up to you to decide. But most people use random. There's another challenge in data called dimensionality, too many variables, so it is huge. Remember the example I told you of the image. You have an image of 500 by 200 pixels.
Those are 10,000 values. So if we're going to save that data here in our spreadsheet, one image will have 10,000 columns. That data is a lot. 10,000 columns is a lot. Some of you are going to use data which is going to be got from just data sets which are just there. They are in the Ministry of Finance. They say, you want data, here it is. And they give you the data and you just look at it and you don't know which one is more important than another. You don't know which one you can say, let us do away with this column or not. They're all the same to you. That one is a big challenge in big data. Although we are saying we want big data, but then when they give it to you, it will now become a challenge. One of the ways you can solve that challenge is by reducing the dimensionality of the data using what we call PCA, or principal component analysis. And this is an example. If you look at this, this graph, you assume that this is data about one instance. This instance has these many dots. You remember when we used to study these things in O-level? And we say, how can we summarize these many dots into one? Let us assume that these dots are representing the pixel values of an image. This is just one image. This is how it looks like. You don't want to have that 10,000 array. You can use PCA analysis to just get the line of best fit. Now this line of best fit, you can choose how many values you want to represent. It can be 2. You just get one, this value here and this other one, 2 or 10. I remember in secondary they used to tell us to just choose 10. So these 10 values are which are going to be moving on this line of best fit. Now you're going to use PCA to reduce the 10,000 arrays to just 10 values. Even one is okay. You've summarized that image into just one value. So we can be able to use PCA analysis to reduce the dimensionality of the data, which has very many variables. And you say it has very many variables, but summarize it into one. You can also choose your own ways of summarizing the data. For example, you can just get the mean. Remember the mean, or median, or mode, or minimum, maximum. Then I think that we have this huge data, but we want to just summarize it into one value, or 2, or 10, or whatever you want. So this is something that you can also be able to do. Look at these two photos. One is of maize, one is of sugarcane leaves. Can you identify a distinguishing feature between these two leaves? One is a sugarcane leaf. Unfortunately, I have showed you the answer. I would have asked you, which one among these ones is maize, which one is sugarcane? Would you have got the answer? You would. What is the distinguishing feature between maize leaves and sugarcane leaves? Yes. The size. He's saying that for sugarcane, the leaves are smaller than the leaves of the maize. Suppose you get a young maize which still has small leaves. Who has another? Yes, please. This one here. But how come this? I also see it here. It's there, even the sugarcane. That middle line, isn't it there? It's there. Any other distinguishing feature which you can think of? Yes, please. The breadth of the leaves. Okay, no problem. So let us say that there are some classes which may be hard for you to identify the distinguishing features. Now for those ones, what do? You just get their parameters and you just throw into an unsupervised model. Let it figure it out. You don't have time to really, think about it. Or you fail to think about it. So that's when you go to deep neural networks. That's when you will choose such models or CNN models, convolution ones. Layers and layers until you learn it. So without wasting your time, that is the end of my presentation. There are very many other interesting things in data handling, but those are a summary which we can go by so that when we are creating our own data sets and uploading them onto these platforms, they can be used by other people. If you are preparing your data set and you keep it to yourself, you may be doing yourself a disservice. Let us up our game in the regard of creating our own data and sharing our own data. Thank you very much. Do you have any questions? Yes, please.
Here comes a situation where a student is going to, he needs to use that data set, but he has no access to a certain data set and is at a proposal level. What would you advise that student to do?
Really, what would you advise a student to do? I think you know the answer to what I'm going to do.
No, I don't know. That's why I'm putting it up.
Really? I would advise a student to create their own data. To just go and look for the data and develop it and clean it up and use his own data or her own data. Because if the data is not there, it's not there. But if the problem is there. So you have to create your own data. How do you create the data? How do you get that data? You go out. If it's questionnaires, you give your questionnaires. If it is focus group discussions, if it's experiments, because you need to make the real measurements of what you're going to do, you do the experiments, you know, then you get your own data. Otherwise, if you say that you're going to look for data and pay for some data, suppose it's not there. Suppose that paper which you read, the author claims that he has that data, but when you send him an email, he doesn't respond. Yesterday, someone met me outside, said that he has been reading my work for fingerprint recognition, you know, and I said, send me the email. But suppose you are not seeing me today during this workshop. Maybe they have my email address, maybe I don't respond to emails, so he'll have to now create on his own data. You don't seem to be happy.
Okay, we shall have another discussion, maybe personal. Okay, one more thing. You've talked about outliers, and you've connected them to vision. You call it vision?
Computer vision.
Yeah. Is it true that whoever uses outliers while they are doing a data pre-processing, they will do a vision like?
Yeah, it is really very good for you to first of all visualize your data before even you start anything. It would be very good for you to just visualize your data, to have an idea, really, what do we have here? But then if you just have rows and columns, you may not be able to appreciate the data, to get an idea what are the patterns of this data. But if you put it in a graph, you visualize it, you can be able even to just see there and then that actually there are 3 classes in this data. without even you know, going through a lot. You can just be able to see them there and say, okay, it seems there are 2 classes, or there are 3, or they are spread in this way. Or even there's no class. So it is really critical for us to visualize our data. Even if it is textual data, we can still make a graph out of it. So let us please, just that there was no time, but then maybe, God liver, in the next sessions, we can have something on data visualization, so that when you have your data, you first visualize it, then you feed it into the model, and then you now see the new model, you also visualize it. Because some people may understand those things of false positive, true positive, false negative, true negative, that confusion matrix, they may understand it, but then they may understand it better if it is visualized. Yeah.
Okay.
And all kind of data can be visualized. Any other question?
Prof, thank you so much. As you have said, data is very scarce in Africa. So what do you comment on using what do you comment on using remotely sensed data in research? Remotely sensed data in research.
My comment is that remotely sensed data is very good, because it gives you a bigger picture actually than you going and doing it yourself. So it is very good, especially if you can map it to particular locations using the coordinates. Then it would be absolutely very good. Maybe the problem will come if some of those, like NASA, denies us access to those satellite images of some places. But then I heard recently that Uganda also did it launch our rocket in the space? I remember as if I was saying, either they were going to or they have done it, please inform me. Do we have it? If we have it, then really, is it in Poma? Poma satellite something. So it is very good. That is very good, because we can now be in charge of our own data with less risks of denial to some pictures. I think that is how Osama bin Laden was even killed, isn't it? They used those satellite images to identify this particular spot, and they killed him without killing many other people. So, can you predict where he's going to go? Since he is now here, you've seen that he's here, you're in the military. You have the data, he first came from there, from there, from there. Can you use that data to predict where he's going to be tomorrow? Then you now launch your artilleries in that place. I hope I've answered your question.
Thank you.
Thank you, Professor. I have a follow-up question. Is synthetic data generally accepted for research? And synthetic data is where you have a very small sample of data, and you use that sample you have to randomly generate similar data. Is that acceptable?
To me, I find that like you're copying, or you're cooking data, you know? You have very little data. It is not giving you your proper results as you want. Now you're saying that, no, let me increase the data, but I don't have time to go and create the data, to pick the data from where I'm supposed to pick it from. It happens if there are few people who have that, like a disease. Like, which disease is rare in Uganda? Do people still have nodding disease, or it ended? Let's talk about COVID. We just talk about COVID because we don't have to go far. We don't have to go far. COVID was in Uganda. People got money to eat do things with COVID. Suddenly COVID has ended. But you had just picked only 10 samples of COVID patients. Now they're no longer patients of COVID. I don't know if they are there, by the way. But just as an example, maybe they are there, but as per now, we don't hear them in the new media for you to know where to go and find them. Are we together? He's asking, can you get your few samples, 10 patients, and you just copy and paste, copy and paste, copy and paste, change some things here and there, then you now run your model. And now he's asking me that, is that okay? Really, what should I say? Should I say it is okay or it is not okay? You help me to answer that question. Help me, because this is a genuine problem which we are facing. Yes, please.
What extent? I was saying, I've read somewhere, and they are suggesting that there are models which can use little data, but I fail to understand to what extent is that little data?
Little. How little is little? Actually, when I was beginning my talk, I said that the smarter the data, the better. As opposed to the bigger the data, the better. So personally, for me, how I would answer that challenge which you're facing, you have very little data. For me, I would not agree with you sitting down and replicating the data, because you would get the same answers if you replicate it. And yet, if you concoct it and you twitch it here and there, it's like as if you're cheating. Aren't you cheating, real? You are cheating. So you use your little data, and you see what to do with your little data. But I wouldn't advise us to, synthesize that data. Yeah, I wouldn't. And the last question. People from this side. Really, I need a question from this side. Or a comment. If you don't have a question, at least there should be a comment.
Hello.
Yes, please.
How do you really believe that this is real data? These data is that they are already on the space or in the cloud are authentic. They are not cooked like manipulated.
It is very similar to what they were saying, that how reliable is our data? How genuine is it? If it can be proved that that data is just, you sat down in your bedroom and you just played around with the data, and then you now shared it to everybody to use, real. If it can be proved, you can even be punished. Because there are laws, there are IP laws. I know of a certain professor, when he was doing his PhD, like my friend there who is doing his PhD, I think he got such a challenge, and he said, let me just sit down and say I did experiments, I did X, Y, and Z. He had results and people were happy, they were good results. They gave him his PhD, but you remember how they revoked the PhD 20 years later. 20 years after getting their PhD, they said this man used false data at his PhD, and then they revoked his PhD, and then they also removed his title of a professor. Yes. Yes. So, ladies and gentlemen, I would like to end my presentation here. Thank you so much for listening to me, and enjoy yourselves.
Another round of applause for Professor. Thank you, Professor, for that talk. I think Professor prepared her slides with students in mind. Her slides are a complete handbook on data preparation. Thank you very much. We really appreciate that. So our professor is going to lead us again through a thought-provoking panel, through a discussion, capacity building in AI and data science. What is the role of universities, industry, and government? So the panelists will be Ms. Stella Quera from URA, Dr. Adam Ali from IUIU, Islamic University in Uganda, Dr. Nibikora Idefos from Busitema University. Please let's welcome our moderator, Professor Florence, and the panelists.
You're welcome, Dr. Ali, Ms. Stella, and Dr. Nibikora. This panel is about capacity building in academia, in industry, and in government. We have a representative from government, that is Stella from URA, and we have two representatives from academia, that is Dr. Ali and Dr. Nibikora. You see, one of the challenges we're facing in AI is lack of capacity. There are some donors, there are some funders who have money for AI. There are many competitions which are taking place in online fora. But you find that few Africans or African organizations are winning that money. So it is important for us to think of how to develop capacity amongst ourselves in the AI community so that we can be able to take advantage of these opportunities. So I'd like to ask you, how is your organization thinking about using AI technologies in terms of capacity building and strategy? Do your organizations have any strategy to improve the use of AI technologies in data science? And I would like to start with our representative, Dr. Ali from academia, to share with us your thoughts on this.
Thank you very much, Professor, my colleagues, and the conference attendees. Universities have tried to create a number of opportunities by, first of all, creating training programs. Now, these training programs are important in a way that they can help the students catch up with the knowledge set. The challenge most of the universities actually find is not moving at the same pace in the same field like other universities abroad. For us, in the Ugandan context, you find that data science is in fact even more newer than what it is in the actual field. If you look at the foreign universities, they will tell you that data science is new, it is 25 years, 30 years. But when we are talking about new here, we are talking about 5 years. And you would find most of our universities right now don't even have bachelor's degree or postgraduate diplomas which are tailored strictly to data science. We are still general. So we have bachelor's in information technology, bachelor's in, for example, computer science, and we don't have specific programs which are tailored in that. Even workshops, our institutions in many occasions don't have those specific workshops tailored to data science. The second thing organizations, institutions are trying to do, I'm saying they are trying to do because very few institutions really have taken into research and development in data science. If we asked ourselves today in the Ugandan universities how many professors are strictly looking at data science as their research domain, you'll actually get surprised. You may find we have Dr. Florence and Dr. Godliver, and there are some few other two, and that's all. So you realize that we are still, the professors are still fewer, and we really need to build a lot of capacity to grow up the current generation to get involved in research and collaborations. In addition to that, we should be able to make short courses, make collaborations, and also create innovation centers. All these may require funding, but I think if we have a good collaboration team, we can always get the funding and be able to make a headway in data science. Thank you.
Okay. You can just give to your neighbor, Stella, and we hear from you. What are your thoughts on this?
Thank you very much. Good afternoon, everyone. From the URA, we have digital strategy that we're actually going to launch very soon. But that said, as an organization, we began some years back with regards to data. Then we have a data warehouse, which was launched over 8 years ago. We continue to make sure that the data we have is clean, and we have initiatives around that, data cleaning, data security. One of the speakers spoke about, do we protect our data? I think it was the Vice Chancellor. We do respect the Data Protection Act, and we talk about it amongst our staff and our clearing agents. As you all know, URA is about taxation, and we are all at developing Uganda together. So AI is very relevant to us. There are efforts they have made to train people. They trained a number of us about 2 years ago. They continue to train. We do source for scholarships for our staff. Some of these things are individual effort, yes, but as an organization, because you know government doesn't really have money, so we rely on development partners for support, but the organization tries to teach its staff. We do have collaborations. We have partners who will train us, not directly like universities, not yet universities, but maybe hopefully that's where we shall go. But AI is relevant to us. We have a few models we've developed to identify HS. We've used this for sentiment analysis, but I will not say that we are at a mature level. We are somewhere. We are starting somewhere, and it's relevant to us. So we look forward to most of you joining us and helping us find revenue in the data. Yes.
Yeah, actually, Stella, before you give your neighbor that microphone, I know that many people here are thinking about what I'm thinking about, that URA has a tendency of kubanjaring people badly, slapping on them fines, and then the businesses end up closing. Does URA think about this and how they can use AI to predict whether if they give this person a fine of 100 million, they will remain in business or not? And if it is there a way in which, is it working? Do you think that it is working according to you?
Thank you. I think I'll begin from the point of accusation that we'll kubanja you until you close. I think it's a misconception. You know, the good stories are never told. There are people who contribute to the development of a country. If you all drove, okay, those who drove from Kampala, the road to Busitema, the university that you're in, the buildings, the government services are from the taxes collected. So we do have good results from government revenue, okay? But usually it's the bad stories that are heard the most because people will cry, they'll put it on social media, it will be all over. The good stories are not always told. However, I do believe that in collaboration with one of the colleagues here said early in the morning that when we're developing these models, how do we engage the industry? He was, I think, talking about agriculture. So when we're developing models, when we're encouraging our students to come up with research papers, who is looking into tax? Who is looking into entrepreneurs? Because that will help us solve some of the problems we have. Sometimes what causes what she's talking about is because people don't know they're supposed to pay tax. Recently, I was looking for taxpayers on social media. Now, you'll find someone has their hustle. They're all over Twitter. They're making money from selling shoes. They are supposed to contribute to national development. This country is ours. It's not for our donors. But we are raised to think that we shouldn't pay tax. Tax is not bad. Because you don't know that you're supposed to pay and you do not want the trouble. You can be a presumptive taxpayer, pay 300,000. That is medicine in a hospital. But we have a bad perception towards tax. So if we can all change in this room and our friends and our brothers, and we bring even that 300,000, it will make a difference, okay? But what happens is it has kind of been like stigmatized. So you think paying tax is bad, URA is out to come for you. No. The problem is because people don't know about how they're supposed to pay tax, which taxes they're supposed to pay. By the time URA discovers you, your liability is high. Yet if you knew that when I started my business, I was supposed to pay VAT, I was supposed to pay as you earn, and you actually paid it at that time, there would not be a distress call, okay? But again, we are working at building models that will be able to maybe deal with such situation, predict how much revenue you would have. But her challenge is basically because Ugandans, you know Ugandans have a poor reading culture. All these things are there. The brochures on how and what you're supposed to pay, your obligation, the laws exist. But no one wants to read about the laws. Okay? So it starts with you, it starts with me. Let's know about our obligations and then we pay. And then we'll collaborate with you and the refactories and Sandbird of this world. We shall have a better country. Thank you.
Thank you very much. Dr. Navikora, we would like your views on what strategy your organization has in place to support capacity building in AI technologies.
Thank you. Ladies and gentlemen, good afternoon. Busitema University, I may not say is the lead, but is among of the universities which is trying to invest in data science. We have a research group, Busitema Interdisciplinary Research Group, headed by Godriva Omugisha. That group is having staff and students from all campuses to do research. They get funding from the university, from science and technology. So we have also developed programs like now, Masters in Artificial Intelligence is on the table of National Council for Higher Education. We are waiting for accreditation. I think that is what I can say, because we believe as the world is moving to digital economy, circular economy, then industrial 4th revolution, we believe data science is the way to go. We cannot. We think there will be more opportunities to young generations. We believe we are going to improve on our lives. Personally, I add my thinking. Any work which is required human judgment, any work which is required human judgment to make a decision, the only way to improve its efficiency is to apply data science. Thank you.
Okay. Thank you very much for your comments. Let us go to the second question due to time. And I will start with Dr. Ali. What is the outlook on curriculum change and how to upskill students and staff to be able to handle these new technologies? You yourself, you said that for us it is still new. We say that AI is still new to us. And we know that the curricula which the universities are using to train the students plays a big role on what they will study and how they'll use the technologies. So what is your outlook on the current curricula in universities in general?
Thank you. I don't know. Okay. Thank you. You know, the shape of the curriculum, if you have been teaching, you realize that most of the traditional curriculums today in many of the universities actually don't have a well-thought depth of data science there because of the fact that it's new. But I would actually think the best way of improving data science and AI and other courses other applications of technology that come on board is through short courses, which are tailored in maybe a week or so, and they should be made in such a way that they are incremental. And they should also be made in such a way that they are interdisciplinary. One thing we don't think about so much as an academia is creating an interdisciplinary curriculum. In many occasions, we have curriculum tailored to IT. We have another one tailored to chemistry. We have another one tailored to, and yet you find the world actually moves or runs on a multidisciplinary knowledge. And all that multidisciplinary knowledge can be put together within a certain defined context in data science. So I would actually think a multidisciplinary curriculum is important. That could be the best way to go. Unfortunately, our education system from the beginning is made in such a way that children go to primary schools. When they leave primary schools, they go to secondary schools. Somewhere within the secondary schools, there is a clear cut between science and arts. You reach at HSC, they tell you now you can do science or you can do arts. And then by the time you reach the university, you find some course IT, and they tell you that it can bring in anybody, but you find you are also incapacitated from your background of some kind of knowledge which is required. So I would actually think that if, as institutions of higher learning, if we can be able to drive the curriculum downwards, instead of the curriculum moving from down to up, then I think we could be able to make a curriculum which is more useful to the current trends of knowledge. But now sometimes you find it's very difficult. For example, how many universities today are prepared in the next 4 years to receive the students who are right now in S3? That's a huge question. Right now, students who are in S3, they are basically moving through competence-based something. When you look at the university curriculum right now, which are going to expire in the next 4 years or 3 years, are we prepared to receive these students in first year? Now, are we prepared to receive students who are doing artificial intelligence? Are we prepared to receive students who have gone through training with big language models? I mean, all these are questions that we ought to ask ourselves as institutions. Thank you.
Before you give the microphone.
Yes, please.
Some of us here in our universities, we don't even have data science course units. Or you find that in the curriculum, there's only one course unit, which is related to data science. Yes. Yet another university may have like 3 course units. So what advice would you give us so that the disadvantaged students can also be able to join or to tap from a richer curriculum?
Okay, one of the ways we can try to tap into having a unified curriculum, specifically for new knowledge set, because if I talk about new knowledge set, I would actually talk about data science being one of them. One of the ways we can be able to harness the value of this is through workshops such as this one. And also maybe create students' forums that have those short courses, such that they are hosted online and students can join them. And then after that, they are recognized. Now, one of the most interesting thing which we normally don't do as universities, we are tailored towards looking for that tuition money from students, or have those, that is for the private universities. For the public universities, you are there to say that, you see, National Council said we need 45 students for Bachelor of Engineering, and that's okay. And we don't actually think about the whole students' population, which could actually gain from a number of activities that we could be able to do each and every time to improve their knowledge. Thank you.
Thank you very much, Dr. Ali. Yes, Stella, what are your thoughts on that?
Thank you very much. My thoughts are for the training institutes, you know, the universities, everyone here, the lecturers who are here. If you could train the labor, you know, our staff, our students, if you could train them end to end. The challenge we have is, for example, we've talked about this aspect. No one has talked to us about how to automate the machine learning, things to do with database. So you send us a guy, the guy can build models, but then what? Doesn't know about batch process, bash, doesn't know about the whole, you know, data pipeline, how to bring the data in, because now that the machine learning model comes at the end. You understand? Because we've done the model, and most of us, the courses you will learn will teach you how to build the model. But they will not teach you how to automate, because every day you're not going to be building, you know? So my hope would be that the lecturers who are here, people who influence the curriculum, if you could think about building a student end to end. Let the student know from the beginning up to the end of the product. The second thing is, I think also you need to consult on what is necessary in the industry. Like he says, you're busy training, but you're bringing out someone who is doing maybe SQL, and in the market we're using Oracle or we're using Microsoft products. So there has to be an effort by the universities or the institutes to try and look at the market every so often. What are you training? What are you skilling people for? What do we need? Okay? Yeah. That would be my thought on the two.
Okay. Thank you.
Sorry, one more thought. We have a challenge also in the industry where you will know all these technical things, but your leaders do not have the same knowledge. So you need to also design programs for our leaders such that you have a training for them on analysis, but which is not too much in depth, but just a little bit, so that they appreciate whatever you're doing. Because you go with all your beautiful knowledge and all this, but they don't get it. So what can they do? They'll probably shelve your ideas. So if you can come up with short courses, 2-week courses, 1 week, that introduce the people to data governance, data quality, and things to do with AI. Thank you.
Okay. Yes, Dr. Nabikora.
Thank you. My thinking is the curriculum should be problem-based learning. Now, suppose we know we have a serious jump in Kampala, whereby we have traffic lights there, but the people are not following. So now, can you design a system for traffic lights? That is one. Two, can you design early warning system for a maintenance for a particular machine? That is two. Three, can you design an expert system for modeling this production line? So somebody, as you move on where you say, I'm running a Python, I'm running R, I'm running MATLAB, but be specific, a particular problem, then somebody can say, I've learned this. Thank you.
Okay. And we're going to go to the last question because I can see we're already 30 minutes into the panel. And the last question is, you know, we have been gathered here by Data Science Africa. What advice or what suggestions would you have to the Data Science Africa organizers? What advice would you give them in terms of what they can do to improve the data science community landscape in Uganda?
I think the best advice I can give Data Science Africa is to continue doing what they are doing right now. Convene the conferences and workshops, and also maybe make boot camps. So that if we called some students, 10 students from each and every university, and then bring them here for 1 week and give them hands-on, and make sure they go back and they train their colleagues, then follow up the students, with the time we can get somewhere. That's the best I can say. Thank you.
Okay.
Thank you. I have maybe 2 ideas. I'm thinking Data Science Africa, Uganda chapter, or even, you know, the whole organization. You need to think about outreach. How do you reach out to the corporates? Because the way I knew about this was because it was on a very interesting basis. You know, having information about its existence is not necessarily known to my colleagues and my friends. And then because it's specific to Busitema University and universities, you know, there's a tendency to think it's about students, you know, yet this is great benefit to other institutions. So I would think it would be nice for you to reach out to organizations, tell them about your existence. You do have the opportunities that were presented, the grants. How do we tailor them for other industries? Not necessarily, okay, I know everyone is interested in health, but what else can you provide for non-health industries for taxation? What else can you do for us? If you could sit us down, or maybe if you do a training for a week and you've invited senior leaders from these organizations, because I'm sure you could get funding for that. Introduce the idea to them, tell them about these scholarships and fundings that exist. Then there will be interest. So instead of just having something that is purely looking at your students, look at us as well. Thank you.
Okay.
For Data Science Africa, I will recommend, you know, having the meeting the way we had it is a bit costly, but we can go to the cheaper way, either weekly or monthly, or try to organize webinars. So we get experts all over the world, then we log in, we keep people learning. Every day we keep learning. If you miss today, but the next time don't miss. I submit.
Thank you very much, my panelists. Dr. Ali wants to add another.
I just wanted to add another thing. One thing I'd forgotten. You, in your presentation, you said that we have a problem of data. And sincerely, we don't have data that is tailored to our local problems. I wish Data Science Africa could create for us a repository which we can be able to use to go through our local problems. Because I'm quite sure data science has capacity to bring all the data around of the research such that we can always be able to also, our students can be able to find that data and they do analysis on them. And maybe also train us on how, or train the students on how they can be able to collect that data. So that if we can collect data from different dimensions, we can put the data together and can be useful for our local problems. Thank you.
Thank you, Dr. Ali. Maybe something I forgot to tell you is that at URA we do have a research lab, and in response to what he says, we do have anonymized data that your researchers can use to model. So you would come to URA and the research lab is available for you. That's something that maybe I hadn't mentioned.
Okay. I would like to give opportunity to the audience to add on to, you've been hearing the questions. Do you have anything you want to add or subtract? Yes, I'll start with my immediate neighbor there.
Thank you very much, the panelists, for the insights. I have a couple of questions, and then I can also add on a reaction. My questions are going towards government, and fortunately, or unfortunately.
Excuse me, please. I'm sorry to cut you short.
Yes?
Don't give us new questions.
No, they're not questions. Okay, let me react.
Yeah, you react and address the questions which you already asked.
Okay.
Because I don't want you to catch our panelists unaware.
No, it was in reference to what we have discussed, but it's okay. Now let me go to the reaction bit of it. Okay, for the curriculum, I think when we were talking about curriculum development, I believe it's high time we bring all the stakeholders together. Academia, industry, and government. Those are the three major entities that need to work together when it comes to curriculum development. We have all agreed that the rate at which technology, those of us who are in the technology field, the rate at which things are moving, it is at rocket speed. Whereas, meaning industry is moving at the same speed with the change in the technology, but academia that is supposed to train the human resource, to take on the mantle, is moving at, I think, snail or turtle speed. Now, when we are looking at curriculum review, academia should try as much as possible to be in constant contact with industry. It's very important. We usually, the two that are supposed to be moving hand in hand are usually decoupled somehow, somewhere. That's the first thing. The other reaction is connecting the knowledge that has been imparted into students. In most cases, universities or academia teaches all this knowledge, as she stated that most of the students are coming when they are doing the AI models, they are able to build them, but connecting, meaning beginning from how do they pick the data, how do they clean it, all of those processes. Actually, academia always does that. The only thing is, there are instances when students are being taught, but maybe the lecturers or the instructors don't emphasize. For instructors, they are going to enter the classroom or the lecture room, rather than starting the class or the course unit by mentioning the prerequisites of the course. They simply dive in. I will give an example from the software engineering perspective. When we teach structured programming, we are literally introducing students to the programming world. From there, we shall have a subject like object-oriented programming, but we are not telling the student why there was a paradigm shift from the structured way of doing things to the object-oriented way of doing things. We simply introduce it and we run from there. A student is not able to think of the connection. Why did we move away from the other side to this side? So most of the students, the reason they come under knowing AI models, let me be more specific to her concern, is because most of those topics are towards the final year. So that's the topics that are fresh with them. Now, my recommendation or suggestion is, the ball is back to us as educators. As we teach these students, let's always try to connect the dots. Tell them, look here, this topic, we are going to do this. Now, when you advance to the next stage, try to connect back. At least you can even use 1 week out of the 15 weeks of the course unit to step back. Use 1 week to remind them where you came from or the previous course units that are connecting to the current course units. Thank you.
Okay, you're welcome. Can we have, yes? Okay, 2 from this side, but there are very many questions. Will they give us more time? I need advice from the moderator. Yes, please.
Thank you. My name is Geoffrey. I just want to respond to the lady from URA. I think a quick one. I think most of these talks that I've been listening for the past 2 days, it's very interesting. But now the problem goes to the industry. When it comes to data science, the biggest challenge, even to the lecturers, is that the industries do not want to put out the problems they face. And they expect us to train students on their problem. Now, my advice, as you go back to URA, you have a website, put out problems that data science can solve. Definitely, you would get the right people to have the smart thinking to solve that problem and give you better insights on how you can also handle some of those problems. Let's say you're dealing, maybe you basically focusing on fraud detection. You've already created a system in URA for detecting people who are not paying taxes. So list the problems out, and definitely people will pick interest and then they work on that problems. There are more than 20 problems, if I'm to mention them, that can be solved using data science. I think the next training is that whenever they are going to handle maybe any data science conference or workshop, or let us come with those problems first that we expect, because whoever is here is really willing to learn to solve the problems. But what problems am I solving? Am I solving customer segmentation? Am I solving fraud detection? Am I solving risk assessment? So make it clear, and then someone will put effort towards that problem, because there are so many disciplines that someone has to invent.
On top of that, just not making it clear, they should also fund.
Yes,
be willing to fund. This is a problem. We can pay this money, do for us something.
Exactly, doctor.
Okay.
Thank you for that.
A last one from this side, then we go to that side. Any other comment from this side? Yes, the last one.
Thank you so much. I would go back to the idea of capacity building, right? For example, how old is my career now?
100.
108? No. Okay, we shall take 100, right? So when we were developing the Ginger suspension bridge, how many engineers did we have from Uganda?
Please, no new questions, just comments.
Yes, one.
No questions, comments only.
Those are comments. I'm building the best for the comments. Yes, so, you know, I want to drive us all to what we call intentionality, which you haven't allowed me to, thank you. But truth is, ladies and gentlemen, we can all talk about data science and all these things. We've talked about how the African data is not there. We've talked about how the African continent has only produced 1.1% of the knowledge available right now, right, for use. But we're going to leave this place, right? 10 months after this very conference, you can do a survey. Nobody here will produce or will collect a data set that will be publicly available. You can trust me on that, because there is no intentionality. So if you are teaching people data science and you're not creating, you're not building an environment where people find purpose and intentionality, then still all these things, we're going to talk about them here and then they go away. She mentioned that at URA they have a research lab, right? But URA has never publicly announced or called for public contribution to that. That's the lack of intentionality, because they have not been taught the importance of being intentional and collaboration. But now that she's here and shared, now we've known. The rest of the world doesn't know. So still on intentionality, if all of us who will leave this conference will not tell other people who are not part of this conference that there is a research lab that's available, and also that the data from URA is available, then still they're going to be, will not see anything produced from that work. So straightforward, universities must intentionally collaborate with the industry, and also the two, after their merger and their collaboration, must involve the decision makers, the government, intentionality. Thank you.
Okay. From this side, yes, you can ask a question, then him, and then her. I need a she. Can I have a lady who will ask a question? But let us first start with... No, we're going this other side. The gentleman in a blue suit. Yes.
Thank you. This is a very interesting conversation, and I would like to contribute to it that most of the times we do focus on the tech, right? AI, data science, big data, and forget that we are building this for the users, right? So my recommendation is we keep focus on the problem we are solving, and because we are solving it for people that are going to use it, it's very important that universities, institutions like Data Science Africa prepare the developers for what to expect in the industry. So what happens is, this is a very complicated domain. So you have to explain it in the simplest way possible to the users and executives. Now, without executive support, your AI, no matter how beautiful it is, it will not go anywhere. So we need to prepare whoever is involved, the soft skills, give them soft skills that will enable them to engage better with executives, with stakeholders. And then as a caution, let's focus on, build AIs in the domain that you understand. If you go on Kaggle and get a data set in public health and you're clueless on public health as an example, you'll end up, removing features that are very important. Simply, you may think, okay, the data set is big enough, so let me just delete this feature. But you don't know how important it is. So for starters, let's focus on, do AI in the domain where we are comfortable. So you understand the data set you're using. That way you'll build better features and you'll build, I think, better AI. Thank you.
Okay. You can give... Is the lady ready? I need a question or a comment from a lady.
Okay, thank you very much. But I would like to... I had the same point like that gentleman about how... Because I'm talking from a private sector point of view, this will directly be going to our representative from URA. I wanted to mention the fact that you put a platform for you to put your problems so that the data scientists can address. But don't forget to also include, we have seen URA doing a lot of systems trying to improve itself to get better, but get better on demanding. The kubanjaring. Now, but we have not seen systems on all you people trying to apply AI and data science on we who you are kubanjaring. How do we get to you? She was giving a good example of why are you not using AI to establish how much is this business capable to pay for? That's one. You were explaining an issue of you've done a lot of good things, but the bad is too much because we are not seeing you addressing us still. We are thinking you are only malicing us. You are not using AI to know that in this particular area of, let's say, eastern region, there was a hailstone and the farmers there are actually not making money using AI, or you can predict that in this particular area. So this is an example of the problem. This time, use AI to include us who are giving you the money so that we are friends. It's a win-win. AI can solve that.
Okay, the last question. No, the last comment from the lady behind.
Thank you so much. I'm called Jimono Grace from Busitema University. When our panelists were speaking, they spoke of less contribution of data by Africans in the entire data that we have. To data science, can this be solved maybe through such meetings of knowledge, of giving knowledge and then sensitizing, maybe putting a repository where people can put data? Can we have a way of solving this issue of having little data that Africans have contributed to the entire data in the world? Can we also put this down? That is not be a story to be talking about Africans are not having data that they are contributing to the world. My next point is maybe to the URA. I'm speaking this as a point of information from the ground that there are a lot of people who are affected by huge taxes compared to the businesses, and this has led them backwards instead of the otherwise. I think with AI or in data science, a model can be built to help allocate these taxes a little bit fairly, that a specific business gets the tax that can still let it continue. Yes, we want the taxes to develop Uganda. However, are we developing Uganda and we also develop, or we are developing Uganda and we fail to develop it tomorrow? Okay, to the academia, the students are taught a lot that is sometimes irrelevant in a particular field or interest. Like one of our panelists said, we get a student who can make webs, but what else? You find that most courses throw a lot of hints on a lot of garbage or a lot of things that someone has to concentrate on to get a good paper, yet may not emphasize on the sensitive points to be an expertise in the field. Thank you.
Okay, thank you very much, everybody, for your contribution to the panel questions. A special thank you to our panelists for your wonderful insights on these problems and challenges. And we hope that we shall implement some of these things that you have raised. Thank you very much, ladies and gentlemen. I think we can now break off for lunch. It is now 1:30. Dr. Fiona, what time are we needed back here? Over to you.
After 1 hour. Thank you very much, the moderator and the panelists. Please let's clap for them. This has been a very vibrant discussion. Professor Florence and our panelists have ignited food for thought concerning the role of universities, government, and industry in the field of data science. As many panelists have emphasized, there are very many avenues in which we can make our contribution, like collecting data to make our data repositories for research, curriculum development, policy formulation, training, and mentoring others. So surely we should all think about what the panelists have said and find a way in which we can grow data science research. Now, like Professor Florence has mentioned, it's lunch break. But as we go for lunch, there is an exhibition. There's an exhibition table on the right when you get out through this door. On the right, there's a table. We have an exhibition from Sunbird, Uganda, and there are also some posters on display. So let's go and learn from the exhibition and the posters as we go for lunch. So let's pass by the exhibition table, and after we have seen the exhibition, then we shall go for lunch, and we should do that in 1 hour. So we should come back here at 20 minutes to 3. Okay, so we started our presidency yesterday of praying for lunch. So may we have somebody to pray for our lunch? Who would like to say a short prayer for lunch? The lady over there. Can we move the microphone so fast to reach the lady? And
let's appreciate God for the meal. Father, God in heaven, we thank you that you have taken us through to this level and you've provided a meal for us. I ask you to bless it. May we enjoy it and have good of it. In Jesus' name I prayed.
And multi-campus public university established in 2007, the university vision is a center of academic and professional excellence in science, technology, and innovation, while T in education. The Faculty of Natural Resources and Environmental Sciences, Namasagali campus in Kamuli, focuses on sustainable use of the environment and natural resources with emphasis on climate change mitigation and natural resources economics. The Faculty of Health Sciences, Mbale campus, focuses on health sciences and is actively participating in research areas in malaria, use of ICT in health, as well as maternal and child health.
What makes me proud of Busitema University? It is the first university in Uganda to implement a multi-campus model. And it's also the first university to bring a medical school in an up-country setting, like where we are, that's Mbale. And now with this, we are very influential in a region which was underserved in terms of medical care. That makes me proud of Busitema University. All of our research has influenced national and international guidelines. And we have published in leading journals, including the New England Journal of Medicine, and I think that's now our frequent place where we publish from. This makes me think we are top-notch in terms of research.
The Faculty of Management Sciences, the Palisa campus, focuses on management sciences, tourism and hospitality, and is carrying out research in business survival, decentralization, organizational rationality and behavior. The Faculty of Agriculture and Animal Sciences, the Arapai campus, focuses on crop production, animal production and agribusiness. Continuing achievements include new innovations in teaching, learning and research that seeks to adapt the higher education subsector to rapidly changing public and private sector skills requirements. The university has been able to address this need through innovative approaches and programs that can produce work-ready personnel for industry and other productive sectors of the economy. Busitema University will continue to contribute to achieving Vision 2040 through innovation, enhancement of technology development, transfer and commercialization of innovations with special focus on enhancing Uganda's engineering, innovative research and development for smart, sustainable and inclusive growth.
I'm really proud of Busitema because we are giving to the community. Busitema has given us an avenue to help our fellow brothers and sisters, and especially the young children.
First and foremost, the university pursues excellence, and that makes us very proud that we are contributing something excellent to the community.
Busitema University, I'm retiring a happy person because I'm leaving a vibrant institution where there was no institution when I walked into Busitema. I would like to see it develop into a world-class university, as my dream was from the very beginning, and has the potential to be so. What makes Busitema University unique is its identity, which we established right from the very beginning. It has unique academic programs. We did not reinvent the wheel. We scanned the environment and identified programs that are relevant to the development of our country.
Highly recognized and awarded, Professor Mary Okwakol, a transformative leader and the founding Vice-Chancellor of Busitema University, is a lady of many firsts in her life. She is the first woman Vice-Chancellor of a public university in Uganda, the pioneer Vice-Chancellor of Busitema University, the pioneer Deputy Vice-Chancellor of Gulu University, the first woman Professor of Zoology at Makerere University, and many more. Her vision and strength saw the birth of Busitema, a Ugandan multi-campus public university established in 2007. The university vision is a center of academic and professional excellence in science, technology and innovation, while the mission to provide high-standard training, engage in quality research and outreach for social-economic transformation and sustainable development.
It is unique in that it is a multi-campus university located in rural areas of the country, unlike the big universities like Makerere, Chambogo, which are in the capital city. By virtue of its location, Busitema University has extremely high potential to impact on rural communities.
With multiple international partner universities and networks, the university has graduated over 6,500 scientists and technicians, 31% of whom are females, to contribute to socio-economic transformation. The university continues to offer academic programs that are aligned to the National Development Plan 2, Vision 2040, and the Sustainable Development Goals. The Faculty of Engineering, Busitema campus in Busia, focuses on irrigation, mechanization, agro-processing, among others, all geared towards value addition and competitiveness in critical national development priorities of human capital development and improved livelihood.
Yes, the Faculty of Engineering is perceived as an achievement of the university because it's among the pioneer faculties. You know, it is a modern facility that you can see students do hands-on training. Why? Because the world now doesn't need theoretical engineers. We need people who are hands-on, who can actually practice. Through the African Development Bank, we are able to get these facilities, which you can see, that helps us to train modern engineers.
The Faculty of Science and Education at the Nagongera campus, Tororo, focuses on science education and ICT in education. The Faculty of Natural Resources and Environmental Sciences, Namasagali campus in Kamuli, focuses on sustainable use of the environment and natural resources with emphasis on climate change mitigation and natural resources economics. The Faculty of Health Sciences, Mbale campus, focuses on health sciences and is actively participating in research areas in malaria, use of ICT in health, as well as maternal and child health.
What makes me proud of Busitema University? It is the first university in Uganda to implement a multi-campus model. And it is also the first university to bring a medical school in an up-country setting, like where we are, that's Mbale. And now with this, we are very influential in a region which was underserved in terms of medical care. That makes me proud of Busitema University. all of our research has influenced national and international guidelines. And we have published in leading journals, including the New England Journal of Medicine, and I think that's now our frequent place where we publish from. This makes me think we are top-notch in terms of research.
The Faculty of Management Sciences, the Palisa campus, focuses on management sciences, tourism and hospitality, and is carrying out research in business survival, decentralization, organizational rationality and behavior. The Faculty of Agriculture and Animal Sciences, the Arapai campus, focuses on crop production, animal production and agribusiness. Continuing achievements include new innovations in teaching, learning and research that seeks to adapt the higher education subsector to rapidly changing public and private sector skills requirements. The university has been able to address this need through innovative approaches and programs that can produce work-ready personnel for industry and other productive sectors of the economy. Busitema University will continue to contribute to achieving Vision 2040 through innovation, enhancement of technology development, transfer and commercialization of innovations with special focus on enhancing Uganda's engineering, innovative research and development for smart, sustainable and inclusive growth.
I'm really proud of Busitema because we are giving to the community. Busitema has given us an avenue to help our fellow brothers and sisters, and especially the young children.
First and foremost, the university pursues excellence, and that makes us very proud that we are contributing something excellent to the community.
Busitema University, I'm retiring a happy person because I'm leaving a vibrant institution where there was no institution when I walked into Busitema. I would like to see it develop into a world-class university, as my dream was from the very beginning, and has the potential to be so. What makes Busitema University unique is its identity, which we established right from the very beginning. It has unique academic programs. We did not reinvent the wheel. We scanned the environment and identified programs that are relevant to the development of our country.
Highly recognized and awarded, Professor Mary Okwakol, a transformative leader and the founding Vice-Chancellor of Busitema University, is a lady of many firsts in her life. She is the first woman Vice-Chancellor of a public university in Uganda, the pioneer Vice-Chancellor of Busitema University, the pioneer Deputy Vice-Chancellor of Gulu University, the first woman Professor of Zoology at Makerere University, and many more. Her vision and strength saw the birth of Busitema, a Ugandan multi-campus public university established in 2007. The university vision is a center of academic and professional excellence in science, technology and innovation, while the mission to provide high-standard training, engage in quality research and outreach for social economic transformation and sustainable development.
It is unique in that it is a multi-campus university located in rural areas of the country, unlike the big universities like Makerere, Chambogo, which are in the capital city. By virtue of its location, Busitema University has extremely high potential to impact on rural communities.
With multiple international partner universities and networks, the university has graduated over 6,500 scientists and technicians, 31% of whom are females, to contribute to socio-economic transformation. The university continues to offer academic programs that are aligned to the National Development Plan 2, Vision 2040, and the Sustainable Development Goals. The Faculty of Engineering, Busitema campus in Busia, focuses on irrigation, mechanization, agro-processing, among others, all geared towards value addition and competitiveness in critical national development priorities of human capital development and improved livelihood.
Yes, the Faculty of Engineering is perceived as an achievement of the university because it's among the pioneer faculties. You know, it is a modern facility that you can see students do hands-on training. Why? Because the world now doesn't need theoretical engineers. We need people who are hands-on, who can actually practice. Through the African Development Bank, we are able to get these facilities, which you can see, that helps us to train modern engineers.
The Faculty of Science and Education at the Nagongera campus, Tororo, focuses on science education and ICT in education. The Faculty of Natural Resources and Environmental Sciences, Namasagali campus in Kamuli, focuses on sustainable use of the environment and natural resources with emphasis on climate change mitigation and natural resources economics. The Faculty of Health Sciences, Mbale campus, focuses on health sciences and is actively participating in research areas in malaria, use of ICT in health, as well as maternal and child health.
What makes me proud of Busitema University? It is the first university in Uganda to implement a multi-campus model. And it is also the first university to bring in medical school in an up-campus setting.
Mr. Dixon is the current head of data commercialization at Stanbic Bank. He has over a decade of experience in data analysis and is a seasoned mentor for Data Hack, for financial inclusion. It's an annual initiative to upskill fintechs and their executives on how to use data and promote financial inclusion. So Mr. Kato is the right person to talk about AI in the private sector. Please let's put our hands together for Mr. Kato.
Thank you, Fiona. Thank you so much. Good afternoon, everyone. Like I've been introduced, my name is Dixon, and I lead the data commercialization team at Stanbic Bank. This has nothing to do with selling data at all whatsoever. I lead an elite team that uses data to solve commercially viable problems. I know we have just had our lunch. I would like to request 1 minute to stretch a little bit, if we may. So we are going to do something very, very simple. We are going to spell Busitema with our bodies. You can, follow me. B, U. Let's continue. Okay. Okay. Thank you so much. Let's take our seats. It is a pleasure to be here to be talking about how AI is used in the private sector. I know yesterday we could have talked about some of these things, but it's a daunting task to talk about AI without talking about big data. Because whereas AI is the simulation of human intelligence by machines, it heavily relies on big data to learn from historical data and be able to predict the future. So big data, by definition, these are large volumes of data that can be analyzed to reveal patterns, trends, but it's not the volume or the size that is most important. What is most important is at the rate at which that data is created, which speaks to velocity, the different types of data, structured and unstructured, and the value that that data has. So data is, very variable. So, like I mentioned, it's very hard to talk about, to exploit how AI is used. If you used Google Maps when you are coming here, chances are you already used an AI application. If you liked a sponsored ad somewhere on Facebook, Twitter, or Instagram, there was AI behind it. And that shows you that the most successful AI programs are those that are embedded within the products and services that we already consume, that you may not even realize that you're actually using AI. But I'm going to try to generally walk you through how different institutions are using, AI. But before I do that, it's important to understand what qualifies to be AI. It's common for, a regular computer program to be taken as AI. So AI is any software or machine that has the following cognitive capabilities. The ability to learn, meaning you feed it with data, and then it creates algorithms based on that data on how to turn that data into actionable information. So the ability to learn from historical data, or the ability to learn from data, reasoning, choosing the right, step by step on how to reach a desired outcome when you're interacting with it. If you're using a chatbot, it has the ability to say, from how this conversation is going, I must escalate it to maybe a sales department. But it's able to reason and use the right algorithm to take a desired outcome. Then the self-collection, it continuously fine-tunes itself to ensure that they provide the most accurate results possible. And then, of course, creativity. If you looked at my first image, that was developed by its AI that produced it. Now, it may not necessarily have all of these, but it must have at least some of these. So that's what really qualifies to be AI. So generally speaking, like I mentioned, AI is within us. We use it even unknowingly, so you cannot exhaust it entirely on how it is used. But these are some from the basics. So the first part, these are like the most common, and then below ones gets more complex. But things like chatbots. There are customer service centers where you even do not recognize that you're talking to that you're talking to a bot, right? You actually feel it's a person, but these are mostly used in the service and support sector. Image classification, we had from one of us building an app to detect cassava diseases. So image classification, generally, and there are so many applications of image classification. Things to do with sentiment analysis to gauge the emotions and mode of your customers. Again, that's one area or application of AI. Recommendation systems. If you've received a call from probably mobile money about more cash or about taking on a product, that probably was informed by a machine learning algorithm that indicated that, hey, Dixon is likely to take on a car loan, or he's likely to take on product ABC. If we go to more interesting stuff, speech recognition, just at the exhibition table, I visited that table, and they have noise detection, a simple device you plant, and it's able to classify the different noise it's hearing. Imagine what it can do in terms of conserving, preserving or enabling animals to be extinct, to identify where they live and protect them better. There are so many applications of speech recognition. deep fake detection. It's so hard. It has become so hard to appreciate which video is legit from what is not legit. Now imagine a scenario where someone creates a deep fake of some president threatening, let's say, launching a nuclear warhead. Now, if you don't analyze that, you could react and actually release yours. So it's a very, very delicate, and I think there's a lot of, it has started to attract a lot of research to be able to identify of the things you watch, the videos you watch, which one is actually legit and which one has been tampered with. So again, so many applications on deepfake detection. So to be able to, so many organizations are using it to regulate content, to know which of these videos or content we are watching that is fake or legit. Gesture recognition, computer vision, to be able to, if let's say, if I walk in with a gun in where I'm not supposed to be, then you could easily say there's about mass shooting is about to happen, right? Computer vision, it could enable interpret. If you're using sign language and I don't, then this can actually help you to interpret the gestures, someone who is using sign language to interpret it for you. Again, so many applications around gesture recognition or posture detection. And then disease detection, both in people and in animals, right? I think it was Dr. Florence, cancer detection. There are so many, in health, it's a game changer to be able to determine or diagnose detect a disease that would have otherwise taken, days and days and days. So we can go on and on and on how AI is being used in private sector, but I would like to narrow this conversation down to how Stanbic Bank is using machine learning and AI. So the AI and machine learning capability sits within the data and analytics department. And there are 4 main units that build AI, AI programs. One of them is the data commercialization. So all these so the data commercialization directly has a reporting line with the data commercialization unit, but these other units have like a dotted line into what they can use AI for. So the data commercialization, like I mentioned, we basically use data to address commercially viable business problems. These are problems that when addressed, you have a clear and disputable way of how they are contributing to the revenue. Data for risk focuses on building models that use data to predict or identify early enough risks and uses data to mitigate those risks. So things around credit risk, who is likely to default, things like who is likely to recover, fraud detection falls under the data for risk unit. We do have the management information system units that again has a set of data scientists that sit there to make sure that some of those repetitive requests that come for reports, what intelligence can be built into that to enable the stakeholders better. And then the RPA, which is the robotic process automation, this is used to auto-discover processes, process automation, and building intelligent processes. So all these units on a day-to-day basis, they have 1 or 2 things they are doing for stakeholders that is related to machine learning. And I'm going to go now specifically on how we've used, this is not exhaustive. Around, I think a few weeks or months ago, Stanbic announced the half-year performance. The net profit was about 200 billion, but of that, 38 was enabled by data. 38 billion. undisputably enabled by data, where we say we recommended ABCD, this one took it up, so the interest that we earned was enabled by data. So this is how powerful and how serious we are when it comes to using data. So first of all, we use data as an asset really to make more money, to provide alternative revenue streams that the bank never thought about. That's what we use data for. And among the things we've done things around risk assurance. That's the credit risk mitigation I talked about, predicting, let's say, if you have 1,000 customers, as an example, who are in default mode, and you have a recovery and rehabilitation team, that's at the bank. Who do you call first to give you money? You have limited resources. It doesn't make sense to call randomly one by one, and at the end of it, the conversion rate is, negligible. So we give them a target list of who to call, to say if you call Dixon, you're most likely going to get to recover from him. Product recommendations, we do it a lot. We use people like Concept to recommend products that you were not sold to. So that's cross-selling. Customer reactivations, I think globally the activation, whether banking or MNO, it's very common for people to sign up for a product and at some point stop using it. So to be able to, one, determine who is showing signs of being inactive in the next 1 month is very important. Then you can proactively engage that customer on what's wrong and what interventions you can do. But two, of those that have already gone inactive, who do you target to reactivate their subscriptions with you? So we use data to do that. Revenue assurance, it's very, very common for either deliberately people doing funny things to either make more for the case of where you have commission-based services. So we use machine learning to make sure that, one, we are correcting all the money we are supposed to correct, and if there is any process that or anything funny that our clients could be doing, then you identify these patterns early enough. Those patterns that might be deviating from the normal business set processes. In channels and distribution, recently, last week I think, we opened 2 customer service points. You could call them branches in Nansana and Kasangati. Those branches were purely informed by data. Using geoinformation system, analyzing the data around different places, combining it with external data, so much data, but some of them how many people use 4G, 3G. Combining that, we are able to pinpoint to say we need a branch in Kasangati and we need a branch in Nansana. So we are using data to inform us where to put the next service point. So the service point could be a branch, it could be an agent point, it could be an ATM, it could be a cash deposit machine. So we are using machine learning to determine where to put the next service point, not using emotions. I think we need a branch here. So these are some of the ways, from a bank perspective, we are using machine learning. As I conclude, it's really food for thought for everyone. Machine learning, best if it's embedded within the services and products that we already consume. So you could, if you're not a student, whether you're a student or not, but how can I use machine learning to enhance my learning journey if you're a student? If you're not, where can you embed machine learning of the services and platforms you use? The question we should ask is, where can I embed? Where can I add intelligence to make the world a better place. Thank you. I welcome any questions.
Thank you very much, Mr. Kato, for this informative presentation. We are now open to questions from the audience. Okay, thank you.
Thank you, presenter. Yes, when you said the machine learning, I was excited to learn more, but I have a few questions. When it comes to assessing risks from the data you have, and the data is, it may be issues of dimensions, and also some variables may be, there could be some interactions. I want to ask you, if sometime you use soft computing to assess, to come up with your models. Soft computing, I mean artificial neural network, genetic algorithm, genetic programming, those ones.
Thank you, thank you. Our deep learning, we are not yet big on deep learning. However, there are a few use cases. I think the customer churn model where we used neural networks, but I think that's an area where we haven't done so much. We use other techniques for now, but it's a journey that we have started. Yeah.
Any other question? We shall take two more.
Yeah, thanks a lot, Kato. Yeah, so how do you ascribe money to something like a recommender system, like that 38 billion? You have recommendations for people to target. How do you monetize that and say this is how much we are saving?
Okay, thank you. So when we recommend a product, we recommend it to someone who initially never had it. So just imagine we say you're likely to take a mortgage, and they contact you and you take a mortgage. So if we had not recommended, they wouldn't have sold their mortgage. So what we do, we calculate any interest earned out of that mortgage. And it's important to note that we don't have, they call it a profit and loss account to say this money should come to data. It's attributed revenue. We just say we enabled you make 1 million from this customer because we recommended a product that they took up. So we calculate any interest, any fees and commission that we earn from a customer that we have recommended a product that initially they never had. So that aggregation from different use cases that we've done amounts to those billions I showed you, 38 billion year to date.
Thank you so much. I'm called Bertha Nantongo, Chambogo University. I know of a friend who's doing some fraud detection in banking institutions, and the challenge was getting that data because it's restricted for almost all financial institutions. So he had to get a few things from like mobile money records, and then ended up doing synthetic data to simulate or to model his research. Now, Since this AI helps you, much as it's academia, because I think that is his PhD research, it could also help you so much, but all institutions did not give, even if at least you would de-identify the customer and give something. So I'm wondering, does Stanbic Bank or other financial institutions help academia to provide this kind of data so that we can also help you solve the problems? Because I think it seems like it is you in your bank who are doing it, but also people in academia have a lot of knowledge and they are not employed by Stanbic, for example. So is there any way you help provide this data after de-identify and people can solve problems you have? Thank you so much.
Thank you. It's a very good question. And I think it should be a question for everyone representing an institution here. Of the data we have, let's say Busitema University, of the data we have, how much of that can we anonymize and share publicly? So and these conversations have started happening. It's very important that institutions are not only the bank, because you might need any other information other than the banking institution. If you get data from Stanbic alone, it may not be enough. So it's an important conversation that we need to start having, and I do hope that Data Science Africa fronts this as one of the, the agendas to promote, to encourage organizations to share some of the data that they have. On our end, we have started. We are building data APIs that would enable third parties to, access some of, the non-sensitive information. It's a journey we've just started, but it's a conversation that each one of us here that represents an institution to start having with the different executives. If, for example, I'm at a university and I publish results on a not dashboard, sorry. I'm used to Power BI dashboards and Tabula dashboards. But if I publish that information on a noteboard, ideally it's somehow publicly accessed, because anyone can walk in and take a photo of that data on the noteboard, right? So why not mask, student numbers and share that information? So I think it's a conversation that we need to start having. It's important. And that will solve the problem of Uganda and Africa has no data for research. Thank you.
Thank you very much, Mr. Kato, for the talk. Please, let's clap for Mr. Kato. I saw a hand too late. So, but we shall have time to network. So our speakers are still available to us. The workshop is still ongoing. So these times that we are out of this room, these are opportunities for us to interact with our speakers, because we cannot exhaust all the questions in the short question and answer sessions. So, and the networking should not end today. We can still keep in touch with these wonderful presenters, and they can continue sharing their expertise with us. So next, we shall have a spotlight talk. So our spotlight speaker is Douglas. Douglas is a multi-faced innovator. He's known for many innovations, among them iBroRets. He will tell us what it is. Kasubo X, which he designed during his senior 6 vacation. Yes, senior 6 vacation. He has Liz. He will tell us what Liz is. It's an electric car. Douglas is also a seasoned speaker. He has given talks on TEDx and also at IEEE events. So his motivation and his interest is making advanced technologies accessible and affordable to the local population. He's currently a bachelor student. He hasn't yet graduated, but he has some innovations under his belt. So let's welcome Douglas to tell us about his journey, inspirations, and his innovations. So, Mr. Onechan Douglas is our first Spotlight Talks speaker. We have other students who also want to showcase their innovations.
Just slideshow. Yes, a very good afternoon, Data Science Africa, Uganda. I am Douglas Onin. And as Madame Fiona, I always refer to her as Dr. Fiona. Probably she's in the course of being a doctor. I am a seasoned speaker and also an innovator. Because we have a very limited amount of time, we shall discover what Kasubo X helicopter is, we shall discover what the LIS is, and we shall dive right into what iBioRIT is, right? Just a second, there should be something else going on. Just a second. I'm wondering why the sound isn't there. So I'm going to be talking to you about knowledge creation, and also I'll dive into what iBioRIT is. But before we dive into the topic knowledge creation, let's have a look at that video. Sound team, why is the sound not up? Why is the sound not up? The sound. No. This is my presentation. It's here. It's here.
Yes, increase the volume of the system of the slide.
Okay, without wasting no time, because as they try to figure out what the sound, or what the problem with the sound system is, that's the helicopter called Kasubo X-18. I developed it when I was in S6. That was the very first one. And it's Uganda's very first safe-to-fly helicopter. I flew it myself as the pilot. Yes. Do we have somebody with a MacBook? A MacBook? You could offer us your charger? Bro, instead. I developed that helicopter way back in 2020 when I was just in S6 in my vacation. The reason why I'm showing you this video is to relate back to what we call knowledge creation, right? We all know that the very first man to develop a car was Mr. Benz, right? But the first driver wasn't Mr. Benz. Mr. Benz did the creation and then he stored his creation. Yeah, it's for C. So what Mr. Benz did was he created the car, but then he kept it inside until his wife got enough courage to drive the car. So his wife becomes the first driver on earth, and also during the driving, when she couldn't brake, she ended up inventing the modern brake system. So they never went to school. She never went to a driving school. She did not know what Harris driving school is. She doesn't know that. She doesn't know what the Divine Brothers driving school is. But she went and drove the car. Mr. Benz did not go to any university. By then, they were using chariots and horses, right? What I'm trying to tell you is that information since the beginning of knowledge creation, it has always been from the industry and to the academia. But the academia's role is to develop this knowledge further and then revert it back to industry where we have improved production. And then that knowledge is given back out for real creation. And it keeps, the cycle continues back to the industry. And then you can have the government, you and I, and everybody else. But a problem that is arising with the African continent is one, that when you look at the knowledge creation, the amount of knowledge that's available for use right now, Africa has only produced 1% of that. And the rest of the world are contributing all the rest. And it's so sad that on the 1% of the knowledge that Africa is creating, none of it is for capital production. None of it is for value production. None of it is for real economic growth. So if I'm to ask you, we just asked you before, during the other session, the panel discussion, how many of you have produced research work? How many? Let me have some hands up if you produce some paper. Yeah? No, just show us. Just
Yeah, if you produced any research paper. You have, right? And Dr. Tabine has, and he has. Allow me to ask them one question, right? Dr. Tabine, you supervised my lecturer, Mr. Henry, who taught me AI, right? And I loved his methods of teaching, and I believe that if I was in your class, I would love your way still, right? Now, if we are to ask you about the research you did, this is just to be honest, right? Not to offend nobody. In the research paper, maybe just give us the title of the research paper. This is not to offend anybody. We're trying to create an environment where we're supposed to learn one thing. Just help us with the title of the research paper. Biometric template. Yeah, biometric template for data security and protection. From that, I would have loved that somebody else from among us or from his colleague picked up the idea and went and fathered it and made some physical production from that. And the knowledge he created must have been an advancement of a piece of information that existed before, and now his work was supposed to be an eye-opener for us, his students, and the students of his students to produce physical product, or at least products that we can make use of, right? The problem is with the African continent right now, the knowledge that we receive are only knowledge of application and not production. So we are here at Data Science Africa. We're going to be going back to our different universities. We're going to be doing data science. So what are you going to use? You're going to use R Studio. You're going to use Stata, SPSS. You're going to use Tableau. You're going to use Survey CTO. You're going to use Python. But in the Python armor of libraries, how many of those libraries are made by the Africans? If you look at the neural networks, how many contributions we've had from transformers, we've come to vision transformers and other versions of the neural network. Let's ask ourselves, how many versions are being made by Africans? That does not require that you have a factory somewhere. It just requires that you sit somewhere, put your mind to work, and then you think about how these models are operating, and then you can give us an improvement, right? But unfortunately, we're not doing that. I told you that 10 months from here, if you pick somebody's numbers, random numbers, and you ask them how many, because remember you talked about capacity building, data creation. If you pick a random number and you ask them 10 months from now, if they really took it intentionally and produced data, you'll be really, really, I think it shouldn't be shocked. You won't be shocked because it's a normal thing not to produce. So ladies and gentlemen, until we accept that it's our responsibility to create data and create knowledge for real production, you will have uranium here, you will have cobalt, nickel, gold, silver, whatever. You will always have Chinese come and extract that. And you know what you're going to do? Your work will always remain to go down the dangerous holes, get dirty, get $1 a whole day, and a rich man is just splashing himself with water, eating amazing food. And you will always remain broke and poor. And you will always keep complaining. You'll always beg, you'll always live by foreign aid, and will never develop. So, I showed you the video because myself, I'm intentionally creating knowledge. There's no engineer in Uganda, there's no university in Uganda that talks about helicopter construction, right? But I created that at S6. I didn't go to no university, but I was just intentional. Now, I'm not trying to blow my own trumpet. I'm just trying to show you how important it is to be intentional about knowledge creation. I speak about this with a lot of passion because it's what we need.
Mr.
Thank you so much. My time is up, but I'm very passionate about knowledge creation. Sorry. Let's go to what I should have shown you.
Mr. Onenchan, I'm just going to add you 1 minute to wrap up your presentation.
Oh yeah, thank you. So the sound team, where are you? There's a video that's supposed to play. That's a device that I've made called iBioret. The sounds to the Mr. Sound. So this device is called iBioret. It's an artificial intelligence powered eyeglass that enables blind people to see. In seeing, it means go to the video. Okay, so what that device does is enables blind people to see, meaning they can read books, they can recognize objects, they can use mobile devices, your laptop, your phone, without them having the eyes, right? They can use that. Plus, they can also walk around the environment without nobody guiding them. So it has several modules inside. We have the object recognition model, we have the reading model, we have the walking model, we have the internet users. So a blind person can now access the internet, do their research. They can access government e-services and all these amazing things. So iBioret is going to affect many fields. Among them, okay, that was the development stage where we started by researching on the blind situation in Uganda. We found about, we'll bring it there.
Thank you, Mr. Onenchan.
Okay,
your time is up, but
let me just play this video if you don't. Okay, very sorry we are out of time, but that's the AI-powered glass that enables blind people to see. The previous was the Kasubo X helicopters. We're now making the plans to make commercial versions, so you can be my first customers. And I also am the developer of Liz, an electric car, which has the potential, the only one to beat Tesla, because you don't need to charge it as it drives.
Thank you very much, Douglas. In my opinion, this is very impressive. Very, very impressive. So we shall have our next spotlight speaker, Mr. Kasozi Akim of Busitema University. And after Mr. Kasozi Akim, we shall have Mr. Ntanda Nasa, also from Busitema University. Then we shall have Liz Kamain from Makerere University. And then we shall have Water from University of Twet. And lastly, we shall have Dr. Viola from Chambogo University. So each speaker is going to have 12 minutes. Okay.
Good afternoon, ladies and gentlemen. It's a privilege to stand before you this afternoon. My name is Kasozi Akim. I'm a student here in Busitema University. I'm pursuing a Bachelor of Science in Computer Engineering. I'm currently in my third year internship, so very soon I'm going to be in my final year. And I am here to discuss the use of AI to improve livelihood. Now, there are so many things around us in our day-to-day life that we use, that we associate with, but we do not even know that behind the scenes there is an AI component. Mr. Kato was giving us some of the examples, and I'm just going to expand a little more. Many of us here, if not all of us, have Gmail accounts, right? And we receive hundreds, if not thousands, of messages on a daily basis. But Google and all these other email service providers are able to filter your messages, to filter out the spams from the important ones. Many of us here, I personally love music. We use Spotify. Spotify has the ability to get your music taste and make you playlists that you can love. YouTube does the same thing. I had a friend who told me, I hate YouTube because I go to make research, but when I open YouTube, the videos that they first put for me, you know, they distract me. You go to research, they put for you maybe a soccer highlight. So the same thing happens in YouTube. They know how to filter out content that you love the most, and they will put it there first. So many of you traveled from different places around the country to come here, and so many of us, a few of us, used Google Maps, and we use it even around town when we're moving around. All these applications use AI. And AI has really made our lives so simple that sometimes we do not get to appreciate it. These are some of the examples I've been speaking about. We also have smart personal assistants. If you have a phone, I'm not beating anyone here, I'm not hitting on anyone, but if you have a real phone, phones come with smart personal assistants these days. If you have an Apple phone, it will have Siri. If you have a Samsung phone, it will have maybe Bixby. If you have a Microsoft computer, it will have Cortana. If you have maybe the Amazon products, it will have Alexa. And all these personal assistants make our lives better. Yeah? You can schedule meetings, set alarms, do what, do this, do that, using AI. But today I am here to mainly talk about a field that is so dear to my heart, and that is the field of agriculture. On behalf of the Busitema AI and Interdisciplinary Research Group, BUEA, we were able to come up with a web application that is soon to become a mobile application that we entitled AgroConnect. Now, AgroConnect has 4 important features, and these features are here to provide a variety of AI-based services that can help improve farming operations. And AgroConnect was designed for a farmer, a simple farmer. The first feature, which is in the AgroConnect app, is the story feed feature. Now, so many times our farmers have not been able to get their products out there. They've not been able to get sufficient information because of their stories are not heard. But with AgroConnect, we provided the story feed page, which is the home page of the application, where farmers can put various stories, right from when they plant, to when they harvest, to when they are taking care of their plants, to when they are maybe facing any challenges. All their stories are uploaded on the story feed page. On AgroConnect, we also have a chatbot feature. And this chatbot feature used, we were able to partner with Sunbird AI, and we were able to use 5 local languages in our chatbot. So many of us use ChatGPT today. We designed an interface that was similar to ChatGPT, but offering you services in your local language. We're able to provide Luganda, Ateso, Lunyankole, Acholi, and Lugbar. And a farmer could easily go there and research about anything, and the chatbot would be able to respond to the farmer in the desired language. Now, how the chatbot worked was how the chatbot works is a user puts their input, maybe how do I plant maize, or when is it best to plant maize, in their language that they have chosen. This is then converted to English by using the Sunbird API, and then it's taken to OpenAI as a request. Then OpenAI generates for us an answer in English still. Then the English is converted back using the Sunbird API, and finally the message is displayed on the screen of the user. Now, all this, like I said, was done in a way that it was user-friendly. The third and the second last feature was the chatting space. We were able to give our farmers the ability to communicate to each other in chatting areas. And they could form groups like we have on WhatsApp, where they can meet together and maybe form a group of goat farmers, beekeeping farmers, and all that. And they are able to exchange ideas, experiences, discuss challenges and possible solutions with each other. The last feature was the market feature, and this was to allow farmers basically to upload or to get to know prices of their market products, or to discuss with the transporters to the different marketplaces to know when it's best to maybe go to the market, among other things. So our application is not yet done. It's a work in progress, as you know. Even WhatsApp has never closed. Everything is improved day in and day out. And we are really, our aim is to get AI involved in all the features of our application and not just the chatbot. And basically, that's how we are trying our level best to bridge the gap by bringing information closer to a farmer using AI. So if you agree with me, all the examples I've given you, from Google Maps to Spotify to YouTube to all these other things that we use in our day-to-day life, AI is the way to simplify our life. And I want to thank all the people that are always giving us access to information. I'd love to thank the people from Sunbird who convey to us their API to be able to use their data. And we also thank all those that will, from today onwards, be able to avail data to us in academia to be able to design these interfaces and applications. So thank you very much for listening.
Thank you very much, Hakim, especially for keeping time. Our next keynote speaker, spotlight speaker, is Mr. Ntanda Nasa from Busitema University.
Good evening to you all. Unfortunately, I've been working here, but when it's my time to speak, things have refused. And we are out of time. Assalamu alaikum. So, what I'm going to talk about is the applications, challenges, future directions, and impacts of AI and data science. So I'll start with the applications. Where do we apply AI? AI is almost applied everywhere today. So I'll start with the agriculture sector. So we can apply AI in precision farming. For example, we have currently AI-driven drones and then sensors that, like for example, moisture sensing. So all that you can use AI. We can also apply AI in crop disease detection. We have the cassava mosaic detection here. Currently, we are also working the Busitema University Artificial Intelligence Research Group. We are working on a coffee leaf rust detection. It's just under proposal that we are going to propose to our mentor. Then we can also apply AI in education. For example, we can have personalized learning. The current technologies that are using that, we have Duolingo, Coursera. Those applications are helping us and they are using AI for you to have a personalized class at any time you want, according to what you want to learn. Then we can apply AI in education, in grading and assessment. For example, you see most of those who like doing online courses, you do multi-choice exams and you are marked instantly. Immediately after doing your exam, your results are given. So that's AI that is doing that. Then in entertainment, we have content creation. Like those who like writing poems, there is ChatGPT, plus some other platforms. We have Jasper, is for those who like creating ads, YouTube ads, Facebook ads. You can use that. Then we have those who like playing video games. AI is also into that field. So other applications in cybersecurity, we have threat detection. For example, the network intrusion detectors that detects and filters traffic, network traffic. Then you have fraud detectors. Also, we can apply AI in natural language processing. For example, we have translators. We have the one for Sandbird, our own. Then you have Google Translator. We have the customer sentiment analysis. Those ones are used in banks and other companies that they look at reports and all what customers want, and then they based on that to provide for the best. Then in finance, AI has been applied in algorithmic trading for those who are doing crypto trading. Yeah, you can have your own bot to do for you some work. Then we have also recommendation systems. Like Kasuza said, Netflix, it can keep on recommending you what you like most. Like also in banks, they apply AI in risk assessments, like Mr. from Stanbic Bank has said, and also chatbots. So, but there are challenges researchers who are doing AI that face mostly. So the first challenge is data quality. Most here in Africa, we don't have data. Like, you take data for granted. So data quality and availability is one big challenge we have. Then model interpretability. For example, if you are to land on a model and they give you its code, there are some things you just see in the code and you don't just understand, just see magic happening. You can even tell, maybe when you ask yourself, why is it like this, that's when you make more research. Then you have bias concerns. Some models that are biased. So that is, if that problem comes within when your training data you're using is also biased, you can rate that. Then there's security and attacks. Most AI tools, they are vulnerable to attacks. So researchers are facing that. Then the last challenge is regulatory and legal challenges. Like currently, there are no well-defined laws that govern AI. Even in Uganda here, those laws are not well-defined. Then let's look at the future directions of AI. So the future directions of AI, they are shaped according to the ongoing researches, technological advancements. So the future, our future, the one we are thinking of in AI, they are depending on that. So we are expecting to have AI for sustainable development. Then we expect to have AI in the health sector. That's why most of the things we are doing right now is just research. We are just doing research and testing. Time will come when they are well implemented, that you don't need to have a microscope to test malaria. You just have to use your phone. That's in the future. Then you shall have AI in education. Time will come when you just have, instead of having one tutor that will teach you from year 1 to year 4, sometimes you have a chatbot teaching you. That's in future. Then lastly, I'll talk about the negative impacts of AI. So AI, it has high costs. When you start working on AI, you spend a lot. You spend a lot from buying data, and mostly some organizations, they don't like, they are so limited to their data, they don't just give it out. You have to buy. Then also, there's no creativity. AI itself doesn't have creativity. It cannot think out of the box. It only does what it's trained to do. It's not like us. It cannot. That's the only thing we are better than it. That for us we have creativity, which for it does not have. Then another impact is unemployment. For example, the robots in the industries, they are automated. So some people who used to do that work, they no longer have jobs. Then AI is making humans lazy, mostly us, the students. In case they give you assignment and you have other programs, ChatGPT does the assignment, we paste and hand in. So are becoming lazy. Then, so that's all that I had prepared.
Thank you very much, Mr. Ntanda. Next we shall have Ms. Lisette Kamen.
Hello, my name is Lisette Carmen and I'm from the University of Twente and I'm here for one exchange semester. But I still would like to give some input into this nice conference. So, if I remember correctly, yesterday somebody indicated his concern about that AI might influence himself with the data that they are providing. That the future with AI might not be the best in the end. And I can follow this way of thought because it is a given that if we are implementing AI, that it will also impact the environment back. So, but this is a future that we are choosing, a future that we are looking for, because we can make impact with AI, and it is impacting us back. So my answer is very clear that we don't need to fear it, but we need to care. We need to take responsibility for the future that we are choosing. We need to take social responsibility. And one way to do this may be citizen science. Citizen science is about including the society, a lot of stakeholders into the process of what we are doing, into science, into data science. So I'm saying if we want to have responsible AI, responsible solutions for the future, we need to look in our environment. We need to look what people want, what the real needs are, and we need to include them in our work. We need real communication and collaboration. And let me give you an example. Let's talk about this nice project on the agro-diagnosis tool. I think a lot of you have already heard about it, right? So it's in general an app that is looking at the plant diseases of the cassava plant. So, and it is using light spectrometer in order to identify it. This is a really nice basis. It is addressing a problem. But let's add a bit more citizen science to it. What if we are collecting the geospatial data? Where exactly are these disease plants? Let's collaborate with the farmers, not just asking them to provide the data. Let's ask them to really work with us, to see us as a partner. And if they are providing the data, we are just the ones that are processing them, that are doing the scientific part before we are giving it back to them. We can map the data, we can indicate some mitigation strategies, what to do. But we are just a small part in the ecosystem which is built upon academics, but also economy and the whole society. So we can be part of this ecosystem and provide our part to them without just focusing on the academic developments. And we can go even a step further. Why aren't we asking these people what exactly do they need? On the one hand, it is quite clear. They need a tool to help them identify if the plants are diseased or not. They would probably like this. I think everybody agrees. But we can also ask them, what kind of advice do you need? What do you need now already about everything? How would the application would look best for you? Which stakeholders would you include in them? Maybe we don't need to work only with the farmers. Maybe we can work with politicians or the reporters or any other institution in Africa. What can they do with the data? Maybe they can come up with policies. Maybe they can come up with whole programs. But we need to ask them first, what kind of input do you need? What kind of help can we contribute? What can we do so that we contribute to a better society? If we do all this, AI might become way more social. AI might be really responsible. And AI can contribute to a good and sustainable society. I thank you so much for listening, and I'm happy to be here in Uganda at this conference, and particularly on this stage right now. Thank you.
Thank you very much, Ms. Lizette, for your presentation. Next, we shall have We'll have Mr. Wuta. Is Mr. Wuta around?
He is not around right now. He is following his funeral from his mother on May. So he might come back half an hour, but he is not here to present right now.
Okay, so we've been informed that Mr. Wuta will not be able to present because he has lost his grandmother. It's a pity. Ladies and gentlemen, we've heard from our future. And from what we've heard, the students who have just given spotlight talks, that's our future. And from what we've heard, the future is bright. Don't you think so? Okay. So we are going to have Dr. Viola from Chambogo University. And after Dr. Viola, we will have Dr. Adima of Busitema University. He has a collaboration call that he's going to share with us. Please welcome Dr. Viola.
Ladies and gentlemen, once again, I've been negotiating for time, 10 minutes. I felt like we are too little to present something, but I think she'll add me more. I think she'll add me more. So, Dr. Viola, as she has said, I'm going to talk about using theories for improved data science research. My doctorate is in informatics. I was glad with this presentation here. It really pulled out exactly what I specialized in. Informatics is looks at the industry and the technology in order to achieve their organization goals. So I felt really relevant to this gathering. I did my doctorate from South Africa. I'm a new doctor in the field. I defended on 16th is when I became a doctor, 16th of August. And I'm graduating on 9th October. Yes, it is Independence here, but in South Africa it's not. So I thank you for this opportunity here. So using theories for improved data science research. Here my audience are researchers, students, and those who publish. It's really very, very important to use theories. If you've been searching here and there different papers, you find that in most cases they don't have these theories. For me, different departments or different fields use different theories. But for me now, I'll talk about theories in the line of information systems, which is under informatics. So that's what I'll talk about. Then computing, yes, mine is a doctorate in computing informatics, so I would like to bring out what is computing. It's all about the science of processing data for storage and retrieval and even use. So those are the fields, computer science and many others. Networks are all under computing. In South Africa, where I was in Swane University, all these are different degrees. One of the students complained of us here teaching students a lot of things, and they don't use them. But in other areas, at least these are different degrees. You find that in Uganda, all these ones are in 1 degree. So we need really to check what we really give to our students. So what are these theories? Theories are just a mental view, the way you perceive something. Because as you come up with a topic for your study, you'll have perceived something. And what you perceive, you get it from society. It's meaning that you're looking at a problem in society in order to have a solution for it. So it's just a mental view depending on your perspective. And this mental view, it has to follow certain principles in order to explain some facts. And these facts now in the setting of research, these are variables. These are variables which you have to look at, and you have to aim at describing exactly what you want this variable to give you, describing it, explaining it, or even enhancing understanding of the world. Now the world is where you're really looking at a problem. Is it in the banks? Is it in agriculture? Is it in chemistry? Or is it in food and processing? So it depends where you get that problem. You look at it in terms of describing it, explaining it, or enhancing understanding of that concept. So why do we use these theories in data science? Sorry. Sometimes we deal with technology and we forget to use it. So why do we use theories in data science research? It's really important because it gives your research a work direction. A work direction in such a way that it gives you how this independent and, sorry, what have I done now? So as I continue, as he works on it to save time, our theories are very important in our research. They give us direction. As we identify the variables, that is the independent and the dependent variables, we tend to, no, next, up. Yes, yeah. So we tend to it helps us to know which influences what. And then also theories help us to validate or disapprove a phenomenon, and that is the situation we are dealing with. To disapprove, that is here now, is where we come up with hypothesis testing. And also it informs us on how to analyze this data. As you read deeply these theories, they'll help you on how to analyze the data that is using different methods of analyzing the data, and also the methodology to use in terms of whether you're using the approach of interviews or even questionnaires and many others. So it guides you on exactly what to use, and even it helps you to design a framework. This is a common thing because the framework helps you to investigate in order to arrive exactly what you need. And even the framework helps you to design the tools in order to have the primary data other than depending on the secondary data. And then when you go back to the design science, it helps you in model fitting if you're to come up or to design a model. And this one helps you to trust the unknown parameters, and these parameters can be the hidden or the latent variables and their indicators. So in information system theories, we have very many of them, and it will depend. You use theories depending on your context. So For the case study of the theory, I'll use the management information system contingency theory. So I'll give a case study of the title of Big Data Analytics Model for Predicting Disease Outbreak Outcomes in Public Health. This was my title for my PhD. So I designed a model for big data analytics in order for it to predict the healthcare outcome. I came up with this topic before COVID came up, but eventually COVID came in. It's like I knew that these diseases will come up. So I designed it in such a way that it leverages. If the public health care accepts to use it, it could help them predict the outcomes after the disease outbreak. So now when you have a topic now, you have to come up with the factors. For my case, the factors were as a result of big data analytics. So challenges. Here I was trying to show that what are these factors which are hindering the adoption of big data analytics. So those are the challenges are categorized into challenges of data, challenges of data itself. The previous speakers talked about them. I want to explain them. The challenges of processing and even the challenges of management. So as you see, these challenges are different, meaning that they cannot be handled by only one issue. For example, if you're dealing with only data and you're handling volume, velocity, variety, then there is also processing challenges, meaning that as you're processing data, as some earlier one said, that there is a problem of pipelining from data collection up to the end when the data is used. So we need to have even data management challenges. So you find that they are different and they're supposed to be handled differently, meaning that we have to select a theory that can help us and address these factors. So for this case, I chose management information system contingency theory. This one deals with the contingency variables. This one now are organizational variables or organization factors, where the organization has to look at the organization strategy, structure, the size, the environment, the technology used, the activities used, that is the task, and the individuals who are working within the organization. And then the MYS variables, now this is for the technology. For this study, the MYS variables, this is now big data analytics. If we substitute to data science, then we look at data science MYS variable. So we look at them as how was it managed, how is it implemented? How was it developed? What is its structure? Does it fit the organization contingency variables, which can help it adopt the use of this new technology? So now we look at the performance. Here, this performance is dropped because we are at adoption stage. We can't evaluate or measure the performance. We drop that column, then we look at the organization performance. So we look at the organization performance. Can contingency variables in an organization really embrace the use of this data science or big data analytics in order to achieve its organization performance? So in this study, I came up with this framework now. So I've integrated the theory constructs into the factors which I have identified from literature. So it is literature which informs you in order to come up with these variables. Then you integrate it. Of course, you have to read in order to incorporate it to come up with a conceptual framework. So you find that I've used the contingency variables, which are mediated by the technology, which is big data analytics, which I need to be adopted, and then it will influence the organizational performance. For this case, I used the organization performance or prediction of public health care outcome. So now, as you come up with a framework, you have to know in mind, what am I solving? What problem am I solving? Earlier on, there was a question that, how do you know what model you're supposed to use? So I never wanted to raise up a hand because it would preempt what I wanted to put across. So here comes the situation. after coming up with the framework, now we are going to look at a problem. What problem are you looking at? Are you looking at the patterns within your data? Are you looking at the classification, association, outlier detections, clustering, regression, or prediction? So that's how you come up with a model to use. So here, each and every problem has its own algorithm or model to use. So I want to go in details because of time. So now when I applied, for me, I used the regression because now I was informed by the theory. So when you read about MIS contingency variable, theory, you find that it uses regression. It directs you exactly that model. Here a model is in form of arithmetic solution or formula. So that's what I came up with. And when I develop it, I have to evaluate it using the test data. All those components they went through them, and then evaluating it, I came up with that solution. And then after evaluating it, now you have to test your model. So I tested my model using the predictive analytics by using exponential coefficients in order to test my model whether it is working. So when I tested my model, I came up with these variables. These variables, I wrote them in abbreviation. The first one is organization structure, environment, big data analytics management, big data analysis structure. So my model accepted these variables, meaning that these variables are the one which can, all these factors are the one which can influence the adoption of big data analytics in public health. So these figures here down, they show that they are odds ratio, because my output of performance was either these factors support the adoption or not support the adoption. So by getting the odds ratio, meaning that the organization tracks that if it increases by 1 unit, 1.7, that means it will accept, or there are higher chances of accepting the adoption of big data analytics, and even environment 0.4, big data analysis management 1.1, and then big data analysis structure 0.7. So thank you very much. I've not given details. For people who want to know the details of this, please you will contact me. But because of time, I wanted just to show where do I end. Okay, so I end by getting the predictive results and also justifying the importance of the model to the industry of public health. Thank you.
Thank you very much, Dr. Viola. We shall have 2 questions regarding Doctor's presentation. Okay.
Thank you, Viola. Just a quick one. You build the model. The only question I'm asking you is accuracy of your model.
Yes, the figures are there. It was accurate.
No,
it was nice.
It's not a lot. It have to be in terms of percentage to say your model is acceptable, is non-acceptable. It's if it is 50%, it's not acceptable. Minimum value should be around 75.
Okay. So should I respond?
Yes, please.
Okay. Yeah, it was 90%. So you can accept my model when I bring it to your organization. Yes, thank you. I have the details.
The last question.
Thank you, Doctor, for your wonderful presentation.
You're welcome.
From what you presented, I've actually seen one model. So my inquiry is, did you design some kind of benchmarking model that you're trying to look at as you're coming up with your final model? Then also the coefficients you're having. Did you have some kind of reference to compare the accuracy of the coefficients you generated of your model, apart from looking at just at the accuracy 90%? Because that happens, but if you go and try to use it practically in the field, it starts generating false positives. And that's a big damage, you know. Thank you.
Should I respond?
Yes, Doctor.
Sorry? I respond to you?
Yes, you may.
Okay. Yes, I compared to other models because remember I told you I was guided by the theory. The theory uses regression. So I subjected my data to regression models, where also I use discriminative analysis. And when I subjected my data to those, they didn't come out, meaning that it is only MR, multiple regression, which succeeded by giving me that. Yes.
Thank you very much, Dr. Viola. Please let's appreciate Dr. Viola for her talk. We are going to have Dr. Adima. He's going to tell us about the different research that he's doing in data science. So that if you're interested in being part of his team, you can speak to him and join him in his research. You're welcome, Doctor.
Okay. Yeah, good evening. I come from the chemistry background, as I already said earlier, and my research is more on natural products. And natural products, basically, we already know what they are. Oh, okay. It's not connected. I used this. So usually connect quickly. Yeah. Yeah, so when we talk about natural products in Uganda, we usually talk about plants, but they are really diverse. We can talk about bacteria, fungi, and these make so many compounds which are the basis of the drugs that we use. And so my inspiration is way back from my PhD, but then I got too much into this when we got COVID. You remember the country was in a dire need to look for solutions to manage COVID. And so there was a call to scientists who can be able to make a contribution. And so what we did was we looked quickly at what has been done in Uganda, and we realized that there are so many people who have done natural products chemistry, and then they have started their activities against different diseases. But all these remains published work in different journals and others in the different universities as thesis. So what we then did was to build a small library of the compounds isolated from Ugandan medicinal plants, and we quickly used this to identify key compounds that can interact with disease targets in COVID and in SARS-CoV-2. So that is what led us to quickly identify the plants that could be used to treat COVID-19. And so at Natural Products and Research Innovation Center, our center is in Mbale at the medical school, we then developed one of our flagship products called a TASCOV. For those who are in Busitema, you definitely know about TASCOV, and it's currently undergoing clinical trials at Mulago Lung Institute, and I'm very sure the results are very promising. And so when we are talking about drug discovery, it's like looking for a needle in a stack of hay. That's pretty difficult. If you have to look for this needle in a stack of hay, it's really difficult. And so we're trying to see how AI can be able to help us find this. This is a typical example of the traditional way in which we can look for drugs. And this is a particular plant called the euphorbia, which is used to treat chikungunya virus. But then traditionally, we would get an extract from this plant and then take it through chromatography and then isolate compounds and then go and test these compounds. But the challenge is these compounds finally do not have any activity. But then traditionally, you tell me, yes, this plant is able to work. So our question is, what do we miss out? So we realize that possibly there are a number of reasons why the activity is lost towards the end. And so how do we address that? And so that is where artificial intelligence comes in. I will not bore you with a lot of things, but there are platforms which are already created to basically search for chemical databases to identify which chemicals are responsible for which activity. But as the talk has been, this can only be possible when there is data. Now, whatever is in here is basically data from elsewhere. In Uganda, you may not find any data. And so at Natural Products Research Center, we do a lot of assays. And then we also have state-of-the-art HPLC machine where we can do fractionation. Our dream is to see if we have a plant, for example, the one that Professor Gwang used, Eusuk. If we have this plant as a key plant, can we be able to identify the key compounds in this plant that are responsible for the activity? As I talked, you only hear about, what was the name of Professor Gwang's medicine? Covidex, yes. You only hear about Covidex, but you don't know what compounds are in it. So what we want to do is to see if we have this crude extract, we run it using our HPLC, and then can we be able to get the HPLC profiles and be able to identify which compounds are in here. But then these diseases are characterized by so many markers. So can we be able to look at the molecular markers and be able to understand how this particular compound works on this disease? And that is where we want to deploy artificial intelligence in our research. Now, the normal drug discovery process takes about 15 years to really have a drug that is well tested and approved by FDA. And so if you have to take all these 15 years, you're spending billions of dollars. And where is this money? The money is not there. So through artificial intelligence, we could cut a lot of the processes and simply have a crude plant extract, do a chromatography and spectroscopy, and then have these signatures and be able to identify these compounds, run them against the different genes involved in this disease process. And then from this, we can be able to identify the key compounds and concentrate on those key compounds. And so that is where we want to be. And that's where we seek collaboration. Yeah, thank you.
Thank you, Dr. Ndima Moses, for that very nice talk on natural herbal medicine. So I don't know if we are close to closing our event right now. However, yes, you have a question? Yes. So I was going to call upon those ones. So the last session should have been, yeah, it's okay, you can see it maybe. Well, it's a question, but I also want to bring it up as okay, I think we can hear from you first, then, yeah, it's okay. No, you can wait. Okay. Okay, let's hear any suggestions or comments for Dr. Ndima, then we go to the next session. About 2 only. Yes.
Thank you. But if you try to look at the sensible sector, for example, I was trying to say that my worry is generally to let me say the whole research area, but most especially in sensitive industries, for example, health. If you try to look at development of AI models, everybody is trying to do it. Students are doing it, professionals are doing it, those who are doing research are also doing it. And the other thing is, these models are actually being deployed to be used by our respective stakeholders without being tested by maybe some kind of organization. You get it? So it's going to actually raise a challenge if really we deploy out there models which are not well trained and well tested to check their accuracy. So my concern is, can we really have some kind of regulation, most especially in sensitive sectors, for example, health, to really fast check models that are going to be deployed to be used in their specific areas? Because this is going to actually, in the long run, affect the health of people or in any other kind of vulnerable sector. Thank you.
Yes, thank you, Doctor, for your presentation. My question is about your samples which you're using. Can you also accept samples from human beings, not only from plants, to do your spectrometry and chromatography?
Thank you very much. Mine is not a question. I just want to react to the brother's concern. It's important to note that currently there is something that we call explainable artificial intelligence. And in explainable artificial intelligence, for such sensitive sectors like health, rather than have our doctors just rush into the traditional artificial intelligence that we sometimes refer to as black boxes, right now, core research is in ensuring that we can have AI that is explainable, that our professionals can basically test and ensure that what they are giving out is the best. They are not risking any patient's life. Thank you.
Yeah, thank you so much. Yes, as he has said, when we are deploying AI here, we simply want to fasten the drug discovery and development process. And we usually integrate this with in vitro testings and in vivo testing. So if we identify a drug molecule, this has to go through the development process, but then we have to do animal models and then also do clinical trials. And so it's usually well regulated and well tested. Where we're only deploying AI is basically to shorten the process. Imagine if somebody picked a plant from Katakwi and then you come with this to the lab. You make so many fractions, you start testing them. And then after testing, like the case I saw there, you invest a lot of money. And then in the end, you find this thing does not work. But then the tools that you use are unable to capture actually the key active molecules. Or there are so many molecules in this plant extract and they work in synergy. So when you are isolating, our experience is that you actually miss out the active compounds because they're in small concentration. So if you miss it out because your technique cannot capture this small concentration, then you may say this plant definitely doesn't work. So then if we do LCMS, that is liquid chromatography, mass spectrometry, we usually get signature peaks. And so we can be able to run this against a particular database. Here you saw the GNPS database, which is now a collection of spectral features of different compounds. And so you can run this against this spectral database, and you can be able to identify the compounds in your extract. If I know them and they're in very small concentrations, then we can design how to synthesize them in the lab. Instead of going through a long process of isolating from the plant and then go and test them, and then it doesn't work, come back to the lab, start from zero. So that is where we're trying to see where, AI can be able to shorten the drug discovery process. Can we use human samples? Yes, most of the health-related studies have to be approved. So usually we go through ethical approvals. So if we really have to get samples from human beings, there's always some ethical approval, and then we can always do this. Okay. Thank you.
I was saying we need to wrap up, and maybe we need two participants to help us give some remarks before I officially call the Dean, Faculty of Engineering, to close the occasion. But I think we had something to do with poster session on our program. Though we didn't get enough participants, so apparently we have like 3 people who presented. It's either first run-up, second run-up. So we think we are going to take that back to the committee to make a decision. And then we also have certificates for you people. And our apologies that we can't deliver them now or give them to you now, but we shall send them to your institutions. We shall post them to different institutions. So I'll invite 2 people to give us their thoughts about all this. We want a female and a male. So if you see a female, raise the hand, so don't. 1, 2 people. Or we can also, I can't say we choose from each university, but let's get representative, 2 people to give us some end remarks. Volunteers. Maybe you may say bring DSA to our university, and you're missing that chance. So, or maybe Ernest, you have something to say for this, or okay? Yes, please come forward. And are you also from Busitema? Okay, good. I need both. Thank you.
Good evening, everyone. My name is Nachmini Martha Taka. I'm a student here pursuing a bachelor's degree in computer engineering, crossing to my final year. Yes, please. Thank you, everyone, for coming out here. Concluding remarks about this, I just want to thank Data Science Africa for organizing this. It has been really enriching to us as the people in academia, because we get to understand these different things and the resources that are available for us to use while we continue in our journey. As people dealing in technology, we have to understand that it's a fact that we need data while carrying out our various things, whether you're in hardware, software, networking. Data is very important for you. And I just want to thank everyone for coming. Thank you very much. Have a good evening.
Hi everyone. My name is Abaho Regan Kashama from Moni University. I'm currently finalizing with my degree of Bachelor's of Science in Information Technology. Particularly, we don't have this course in data science in our course, though we do something related to it, like business intelligence, something related. But I had a desire to know more about data science, and I think this session has really sparked my interest to deep dive into data science, and it has really connected me to some potential experts whom I wish next time I have an event at my campus, I can easily spot out one and lead us. Otherwise, I'm really excited for this session, and my suggestion or my request is you could make this chapter to be at the campus level. Like each campus to have a chapter where students can intervene and discuss about these issues related with technology and artificial intelligence and so on. So I think that would also serve better in the future. It's just a suggestion. Thank you so much.
Thank you very much for your wonderful remarks. So, all noted. I think we shall have to act, or, we actually have even a WhatsApp group. If you haven't joined and you have questions like this, or you need help somewhere, or someone could help you within the group, I think better join so that the eastern part is not left behind. And Data Science Africa also has a main WhatsApp group. Also, you can follow us on Twitter, on all our platforms, right? So don't stay behind because you're lacking information. I'll invite Deputy Dean, Dr. Nibikola, to come and close our session. Thank you.
Good evening, everyone. This is a very good opportunity to me to be here and give you the final remarks and close the workshop. My name is Dr. Nibikola Ildefonse. I'm Deputy Dean of Faculty of Engineering and Technology. For me, I did textile engineering. But I've been doing research over 20 years using machine learning. We normally, if I can try to to summarize, if you are seated in the car and you see there is some sign showing the fuel is about to end, right? Or the seat belt, the belt is not fixed well. So these are early warning systems. So the application is for industries whereby the machines need to be maintained, serviced, or just in quality control. For instance, in textile, when the fabric has come out, there is a professional who have to see there is no defect. So now in machine learning, we have to have, we develop a machine vision to see there is no defect, there is no line, there is no hole, there is no what. So then there is those things with image visualization, clustering, things of object detection, we all use in that field. So my prayer is data science. People call it is a new thing. It is a new field, but yes, it is new. But the way it have come, it have to move at high speed. Why? Because today everyone wants to have smart products, whereby in engineering we have like over parameters which we need to control: the speed, the height, the weight, the volume, the efficiency, many things. Now, whatever products we are having, we want something to be able to control or to monitor whatever device you are using. So today we want to have, if your product is not smart enough, it cannot stay long to the market. So these 2 days I have been learning a lot. For me, I have just a little. I've been programming in MATLAB over 20 years, but other new languages like Python, I'm just learning now. But it is good to have a network. You know, Africans, we have bad, anyway, let me not call bad, but we hide information. Let's give information to others. Let's build others. You know, let's build the younger ones, because tomorrow they are the ones who is going to support us. So that's what I was proposing. Let's have webinars, because physical meetings, they are very expensive. But to build our nations, to build our futures, we need to give information. We need to teach one another. So let me not take long on that. I just want to thank everyone for coming, for sharing your knowledge, your innovation, whatever you have done. So my prayer is, as I said, physical is expensive, but let's keep this group from other universities, from Data Science Africa, from public sector, because these days we are in digital technology. We are in this time whereby we can communicate easily and frequently. So I want to wish you everyone a nice evening, a safe journey where you came from, you return safely, and God bless you. Thank you.
Thank you, Deputy Dean, for closing our workshop. So our workshop has been officially closed, but we have evening tea and, of course, networking. We are going to leave this place with many research groups so that next year when we meet, we shall be presenting what happened, what came out of the networking that we are doing. Please feel free to interact, make connections, and there is evening tea outside. Thank you.